starting from this section, we will be entering the advanced phase of web development. To make any website look well organized and structured, positioning of the elements is the key factor. Now, when it comes to positioning elements, CSS offers a wide range of rules, and these rules are categorized as CSS page layout techniques. With the help of page layout techniques, you will be able to control every element's positioning which you have defined on your web page. And by positioning, I mean elements spacing, margin, arranging the elements in row and columns, that is creating a grid layout or creating a fixed or responsive web page or designing a fluid layout and much more. As of now, we have seen some common page layout properties like margin, padding or borders, but in this section, we will be looking at advanced CSS concepts like floats, flexbox, grid layout, and the display property, etc. By the end of this section, you will be able to control every aspect of the element's positioning and will develop a better understanding on how the elements get distributed on the web page. CSS box model is actually the way CSS handles every element. And before I further explain box model, let's first observe an example. I'm going to create a main division, that is parent division, with class name container, and I will pass a message here saying box model. Let me create another subdivision with class name content, and inside I'll define two more subdivisions, my heading and topic. Now for the styles, I'll apply simple styling to them like font size, color, margin, padding and text alignment. Now observe this. I'll open the dev tool and I will select the inspect element option. Let me roll over the mouse on this element. You can see that there is some box like area getting highlighted. In fact, when I roll over the mouse on any element, you can see box like area getting highlighted. You can say this as a box which is appearing for every element. What this means is every element inside CSS is treated as a box, and that's why it is CSS box model. In short, CSS treats every element as a box when it comes to applying the CSS rules. Let me select an element. When I scroll down a bit, you can see this layout which is being displayed at the bottom of the styles tab. Now when I roll over the mouse on these sections, you can see that particular section is getting highlighted in the browser as well. As the border does not contain any value right now, it is not getting highlighted, but that does not mean it is not available at this time. It is present but just transparent right now. When I select this element, you can observe here that it is displaying three properties, that is padding, border and margin. So this is what the basic definition of a box model is, that every element is treated as a box that contains properties like content, padding, border and margin. So understanding these boxes is key to being able to create more complex layouts with CSS or to align items with other items. Now let's talk about the parts of box model. First, we have the content. It is the area where your content will be displayed. For example, image, text or any other forms of media content. To modify the content dimensions, properties like height and width are very helpful. Then we have the padding, which sits between the content and a border as white space. It is applied to all sides of the box, that is top, bottom, left and right. Next is the border, which is the area that wraps the content and the padding. Remember that every element has its own border. You just have to switch it on or maybe off, which is by default. Like here, if I give border to the heading, now when I inspect the heading, you can see the border gets displayed. So it's not that I have placed a separate rectangle here to show the box. Every element has its own border. You just have to switch it on to show it. Lastly, the margin. Now margin is defined as the distance between two elements. It wraps the border, padding and the content. Margin does not have any background color and is completely transparent. So this is what a box model is. We will be seeing padding, margin and border in detail as we move ahead. Let's talk about questions. So what is a box model in CSS? So every element in CSS is treated as a box. That's what a box model is. Every box model, every element has content, padding, border and margin. So these are the four properties you use with different values to format the content using CSS. Every element you define inside the web page has its own border, and CSS provides a way to switch the border on for any particular element. By default, the border of any element is going to be in a rectangular shape. For example, let me define few elements here. I will give a heading, creating a division and defining a paragraph inside. Now all these elements which I have defined have their own borders which cannot be seen right now because I haven't switched it on. So let's try to give a border to this heading. Now the border for any element is defined by specifying the border style, border width and border color. So let me go ahead and give border style. You can give various styles to the border. As you can see, there are various options for styling the border. I will keep the border style as solid. Next is the border width, which defines the thickness of border line. Now this takes length values as well as keyword values like thin, thick and medium, but generally we see that length values are used more often so that they can relate with other properties or designs. I'll keep it 5 pixels. Remember, the more width you give, the more thickness it will add to the border. At this moment, you can see the border is getting displayed. If you won't specify any color to the border, then it's going to take the default color of the element or parent element on which the border is applied, which is in our case white. If I give the color to the element, you can see the border by default takes that color. So to give the border a different color, you will have to give the border color property. And you can see now the border color is different from the element's color. Let me go ahead and define borders for every element we have given. So like I said earlier, that every element has its own border. You can see this division has its own border. This paragraph has its own border as well. Now there is a shorthand property which takes all these values in a single property, and that is the border property. We have already seen this and have used it many times. Normally the syntax goes like this, where we first define the border width, then the border style and then the border color. But the sequence does not matter at all. If you want, you can start with color first, then width and then style, or you can come up with any other combinations. Now there are properties which let you define individual borders with different width, color or style values for each side, like border top, border bottom, border left or border right. You can see this in the snippet. All these properties will let you define different borders for each side of an element. And if you wish to add some border radius to reduce the sharpness of the border edges, you can use the border radius property, which takes length value affecting the edges of the border, as you can see. So this was about the borders and how you can apply them. Padding creates a space between the element's border and its content. Let's understand it with the help of an example. You can see here I have already defined an H1 inside a division. Now I am going to apply padding on this division. So in the style, first I will apply some border on this division so that you can get a better idea how the padding affects the element. Now I will give padding 50 pixels. You can see that when I gave this padding, the H1's content got shifted because now that area has some padding on it. Let me show you. I'll open the dev tool and let me inspect this division. Now in the box model, when I hover on this padding, you can see the exact area the padding is getting applied, which is always between the border and the content of an element. Similarly, let me give padding to this H1 as well. I will give border and padding of 30 pixels to H1. Now when I inspect the H1 and hover on the padding, you can see the padding area of H1. Also, you can see we haven't applied any margin for the element, but by default, it is taking some margin. So let's set the margin to 0 for better understanding. Now you can see the additional space created by the margin is removed. You can set the padding of any element individually for each side or all sides at once. Like right now, both the elements padding, that is this 50 pixels and 30 pixels, is getting applied on all the sides of the element, that is top, right, bottom and left. They are all equal. But if you want to give different padding to each side, you can easily do that. So to give the top padding, I will give the padding top property. Similarly, I will give padding right for right side, padding bottom for bottom side and padding left for left side. So now I have given different padding values to the sides, and when I inspect this division, you can see the area of padding. Now this might look like a lengthy way to define padding to the sides. So to avoid this, there is a shorthand where you can define these values in a single line. Let me give padding. I'll give these 4 values here. So padding takes up to 4 values maximum, and they are in the clockwise order, also known as TRBL, that is top, right, bottom and left order. The first value defines the top padding, the second is right, the third value defines the bottom padding, and last value defines the left padding. So this is the order which you have to keep in mind when giving multiple values to the padding, that which value is going to affect which side. If I give 3 values, let me change this to 30 pixels. Now when there are 3 values, then the first value will define top padding, the second value will define right and left paddings, and the third value will define the bottom padding. If I give 2 values, then the first value will define the top and bottom padding, and the second value will define right and left padding. Now things get pretty interesting when you give percentage value to the padding, because when you give percentage value, then that padding is defined based on the parent element's width. Suppose I give 10% padding to the H1. Now when I inspect this H1, you can see the padding is approx 22.4 pixels. How? Because the pixel value for 10% is 0.1 pixels, right? Now this is how the padding gets calculated with percentage units. Let's check the width on the parent element, that is this division. So if I inspect this division, you can see it has a width of around 224 pixels. So the padding gets multiplied with the width of the parent element, that is 10% into 224 pixels, which equals 22.4 pixels. Let's check it one more time. This time I will define width to the division. I will give 350 pixels width. Now when I inspect the H1, you can see the padding has changed because the parent element's width is different. So the padding of H1 is getting multiplied with the parent element's width. That is 10% into 350 pixels, which equals 35 pixels. This is how the padding gets calculated. When given in percentage, it will always relate to the width of its parent element. Let's talk about questions. So why do we need padding in CSS? Well, when you want to create a space between the element's border and its content, that is where you define the padding property. The second question is, what is the order of values with respect to the element's side in padding shorthand property? So the order of values is top, right, bottom and left, that is TRBL, which goes in the clockwise direction. The third question is, what happens when you give padding in percentage? So when you define padding in percentage, then that element's padding will relate to its parent element's width. That is, the padding will be multiplied with the width of the parent element. Just like padding, margins are used to create space around the elements but outside the element's border. As margin is the outermost portion of the box model, it creates a space outside the element's border. Let's take a practical example where I have created a paragraph inside the division. Now for the styles, I will start by giving a border to the division. And for the paragraph, I am giving a border and padding. Now watch the output. When I give margin 50 pixels, you can see it added the space around all the sides of the element, outside the element's border. Just like padding, it takes up to 4 values representing each side of an element in a clockwise order, that is top, right, bottom and left. Right now the margin is 50 pixels for all the sides, as you can see in the box model. If you want to give individual margin to all the sides, you can make use of these properties: margin top, margin right, margin bottom and margin left respectively. To set all these property values in a single property, you can use the margin shorthand property. Like here I've given 50 pixels, that is single value, which makes all the 4 sides of the margin equal. So if I want to give different margin values to all the sides, I will have to give 4 values here. First value for top margin, second for right margin, third for bottom and fourth goes for left margin. Similarly, if I give 3 values, then the top margin will be 50, right and left will be 100 and bottom will be 60 pixels. And when I give 2 values, then it is top bottom margin, that is 50 pixels, and right and left, that is 100 pixels. Now each of the margin properties accepts a keyword value, auto. This keyword tells the browser the margin for you. In most cases, a value of auto will be equivalent to a value of 0, which is the initial value for each margin property, or else whatever space is available on that side of the element, auto will consider that value. Auto is very handy when it comes to horizontally centering the element within its container. So if I give width to the parent container and specify the margin to auto, you can see the element is now center aligned. Considering the width specified, the remaining space will be filled up equally by the left and right margins. Without the specified width, the auto value would essentially have no effect. Also, the auto value is useful only for horizontal centering, so using auto for top and bottom margins will not center an element vertically. Let's talk about questions. So, how does margin differ from padding? A margin creates a space around an element's border, while padding creates a space between an element's border and the content. In other words, the margin property controls the space outside an element, and the padding property controls the space inside an element. You can also say that padding is the closest property to the element's content, while the margin is the farthest from the content. Second question, how can you center the element using auto? When you have specified the width of an element, setting the margin as 0 and auto will make the element sit centrally within the parent container. Specifying auto as the second parameter basically tells the browser to automatically determine the left and right margins itself, which it does by setting them equally. It guarantees that the left and right margins will be set to the same size. The first parameter 0 indicates that the top and bottom margins will both be set to 0. But remember that this only works on the block level elements, and the auto will center the elements horizontally and not vertically. It does not set them vertically centered because the W3 specs for CSS are designed in such a way. Margin collapsing happens when the vertical margin, that is top and bottom margin of two block level elements, sometimes gets combined, that is collapsed into a single margin. To illustrate this, let's check an example. I will define two elements, say heading and a paragraph. Now let me apply border to them. So I will give a border to H1 and a border to paragraph. Now let's apply some vertical margin between them. For H1, I will give the bottom margin of 60 pixels, and for the paragraph, I will give top margin of 20 pixels. Now when I inspect this paragraph, you can see the top margin area getting highlighted, and when I inspect the H1, you can see the bottom margin area, which is till the paragraph element, that is the margin touches the paragraph element. What really should have happened is that the vertical margin between these elements should be a total of 80 pixels, that is 60 plus 20. But eventually the margin collapsed, and now the actual margin remains 60 pixels only. This behavior is known as margin collapsing. To avoid this, there are ways like using flexbox or grid layout or even padding in some cases. But first, you need to keep in mind that margin is meant to increase the distance between siblings and not to increase the gap between a child and its parent's bounding box. That's what padding is for. The more you will work with margins, the more you will understand its functionalities, and you will be able to point out where the margins are getting collapsed. There is one more concept, and that is negative margins. If I give here minus 20 pixels, then you can see the paragraph is pulled towards the heading, that is margin has decreased. Negative margins allow us to reduce the space between two elements. It lets us pull a child outside its parent's bounding box or reduce the space between siblings until they overlap. The collapse of negative margins is same as the positive ones. Whichever margin is dominant, that is greater, will show the significance. If I change the bottom margin of heading to 20 pixels, then the margin will have no effect, as the positive margin and negative margin cancel each other out. Negative margins are used when you want to remove unwanted margins, like by applying negative margin to a parent element, you can cancel out unwanted margin. You can also give multiple negative values to remove or adjust the space between the elements. So these were the few important concepts related to margins. Now let's talk about relative questions. The question is, does the margin collapse horizontally? Well, absolutely no. Margins never collapse horizontally because it simply does not satisfy the conditions which make a margin collapse horizontally. Only vertical margin can get collapsed. The second question is, what causes margin collapsing? Collapsing of margins happen when two vertical margins come in contact with one another. If one margin is greater than the other, then that margin overrides the other, leaving out one single margin value which is the greater one. The float property is very important when it comes to giving flexibility to your web page. Think of a float property like this. When you define the elements on the web page, they all have some sort of fixed position, like they are rigid. But by giving float property to them, you are allowing them to float freely anywhere on the web page. Let's look at an example. I'm going to create 3 divisions and name them as element 1, element 2 and element 3. Now I'm going to apply few styles to the division. It's going to be common for all the divs. I'll give width, height, margin, font size, border, the radius, text align and line height. Right now we have got a normal document flow. That is, you can see these elements are in their normal state. They are stacked in an orderly format. Now with the float property, you can give one of 5 values supported by all the browsers. That is right, left, none, initial and inherit. Let's see what happens when I give float right to element 1. You can see the element 1 is now at the extreme right side of the document and the divisions 2 and 3 are shifted upwards. So when you apply float on any element, that element is taken out of the normal flow of the document and the below element will take that space because now the space where element 1 was at is empty, as the element 1 is removed from the normal flow of document. So the non-floated element will consider the empty space and fill that up. Now observe what happens when I float this element to left. You can see it is overlapping the element 2 as the element 2 and 3 are still in the normal document flow. They are still filling up the empty space of element 1 as we have removed the element 1 from that flow. So you are allowed to overlap other elements using the float property. Similarly, if I float element 2 to left, then element 3 comes underneath element 1 and element 2 comes aside the element 1 as it got removed from the normal document flow. If I float the element 3 to left as well, you can see a queue-like structure. This technique is very useful when you want to make a photo gallery-like structure or horizontal menus. Now let me float all the elements to right. I will give float right to the division element and remove all the previously defined floats. So all the elements are floated to right. You can see how it affects them. Now if I float the element 2 to left, you can see element 3 fills up the empty space as element 2 is floated left. Now let me change the value to initial. The initial will bring the element back to its initial position, but as element 1 is floated right, element 2 will fill up that beginning space. If I also give initial to element 1, then you can start seeing the default structure which we were at the beginning. The float inherit will simply inherit the float property from its parent element, and the float none will clear out the float applied on the element. Let me give none here to element 3, and you can see it clears the float on it and brings it back to its default place. The only difference between the initial and none is that initial is still a floating value which tells the element to float at its initial position, while the none will clear out any floating applied on the element. Float is also very useful when you want to wrap the text around the element. Like here, let me give paragraphs after each division. Now what I want is, I want to move these paragraphs next to their divisions. First, let me give padding to the paragraph. So I will apply the float like this. For element 1, I will float it to left, for 2, right, and for 3, left again. And you can see how the text wraps around the divisions. So understanding and mastering floats is very important, because apart from just wrapping text around the elements, floats can be used to create an entire web page layout. We will see various situations with floats as we move further. While floating is used for creating a web layout, the clear property, on the other hand, is used to clear out the floats from the element to restore the normal document flow. Together, the floating and clearing allows us to have precise control over the flow of layout. Clear property can have one of 5 values supported by all the browsers, and those are right, left, both, none, and inherit. So let's check out these values. I am going to continue with the example which we saw in the previous lecture. I am going to make few modifications to it. First, let me remove all the paragraphs from the HTML file. Next, I will remove the border radius and all the float properties, and also let me remove the paragraph class. Alright, so you can see we have 3 rectangles stacked on one another. Now I will set element 1 to float left and element 2 to float right. And as usual, we have overlapping problem as we have seen in the previous chapter. I am going to give the different heights to the first 2 elements, that is element 1 and 2. I will set 200 pixels to element 1 and 300 to element 2. And also let me set the width of element 3 to 95%. Now it's clearly visible that element 1 and 2 are floating and they are overlapping element 3. So let's solve this by using the clear property. In element 3, I will give clear left. This means it will not allow the elements to overlap that are floating left, but elements that are floating right are allowed to overlap it. Now if I change it to clear right, this means it will not allow the elements to overlap that are floating right, but elements floating left are allowed to overlap it. Let me set the height of the element 1 to 400 pixels, and you can see element 1 is overlapping element 3 again. Now if I change it to clear both, it will not allow any floating element to overlap on it, as you can see. Element 3 will be shifted at the bottom side of the element which is having the maximum height by not allowing any floating element on it. Let me reset the element 1 height to 200 pixels again to confirm. Now clear none will reset the element position back to normal as per the document flow, whereas clear inherit will just inherit the parent property of clearing the flow. Remember that giving float and clear property together inside an element is not a desirable approach. You can give them together, there is nothing wrong with that, but when you float an element and clear a direction, you are simply adding a page break to the document flow. If the cleared element is followed by another floated element in the same direction, it's going to float in the given direction like here. Let me remove all the height and width settings of the elements and set the floating to right. Now when I clear the right side of element 2, you can see that element 2 and 3 are brought down. So this was all about the clearing of floats. It gives you a precise amount of control over which elements you wish to float and which elements you wish to bring back to normal document flow. Let's talk about relative questions. So the question is, how can you control the behavior of floated elements? If you don't give the clear property, then the elements will overlap or clutter up with the existing floating elements. When an element is floated, it is taken out of the normal document flow. Now this creates a situation where the containing block, that is the parent element's height, may get collapsed, making it look like as if the child elements are no longer inside the parent container. This behavior can cause many unwanted situations, like the background of the parent container gets disappeared or contents within gets overlapped, etc. So let's create an example for the same and we'll see a few ways to avoid the collapse. I'm going to create a parent division which will contain 3 child divisions. Now I'm going to apply some styling to the parent division like padding, width and border. And we'll also style the child divisions, but before giving individual properties, let me add padding and margin to the child divisions. I will use the child selector for that. I'll give background color to each child division. Now observe what happens to the parent container when I float every child division. You can see the parent container getting collapsed. That is, the height of the parent container gets 0. If you want to check, let me open the Dev tool, inspect the parent division and go to Computed tab. You can see the height is 0 pixels because the height of the parent division is based on the number of elements which are inside, as we haven't given any height to the parent division explicitly. There are many ways to avoid this kind of collapsing, and being a front-end developer, you will face many different situations like this. So the first way is simply float the parent element in whichever direction you want, but mostly in the same direction as the child elements are floated. If I give float left, then you can see the container is back again the way we wanted. Another way is to give height to the parent container. Or you can define a blank paragraph and apply clear property to it. Why only empty paragraph? You can also give text inside. It will solve the problem as well. Let me undo the paragraph HTML and CSS both. If you do not want to add any extra elements, then there is another approach in which you will have to give the property called overflow inside the parent container. What overflow does is, it defines what you want to do with the content which is too big to fit in that area. It takes one of 4 values, that is visible, auto, hidden and scroll. We will see this property in a more detailed lecture, but right now let me just give hidden. Hidden is going to clip off any content that overflows from the area, and you can see it stopped the container collapsing. So these were the few ways you can use to deal with collapsing of the container. Now, collapsing is an important factor to be considered, which you want to prevent, otherwise it leads to strange layout and cross-browser problems. Let's talk about relative questions. So, explain what is container collapsing, or why the container gets collapsed when elements are floated. So when all the elements inside the parent container are floated, the height of parent container gets collapsed, that is, it gets to 0 pixel. This happens because all the floated elements are taken out of the normal document flow, so the parent element does not recognize the sizes of the floated elements and acts as if nothing is contained in it. As a result, it is set to 0 pixels. So this is what container collapsing is. In the previous lecture, we saw different methods for handling container collapsing. Now all these methods may get the job done, but developers still face issues regarding the page layout after performing these methods. So they came up with a newer way which prevents collapsing of containers and also don't mess up the page layout too, which they named as ClearFix method. So let's see how it works. I'm going to define a division with class name ClearFix, which will contain 2 images. I will define image tag giving the source and width, making a copy of this image tag, and lastly will give a paragraph. Now I'm going to float all the elements so that the parent container gets collapsed. First I will give border to the division. Now I will float the elements. You can see the container has collapsed. Now the ClearFix approach makes use of the after pseudo element because it adds a content after the element. So this way you can clear that content and avoid the collapsing without adding different block elements to the document and then clearing them. So I will go ahead and give the after pseudo element to the div and I will keep the content empty. Next, we make sure the visibility of this stays hidden. So I will give visibility property and set it to hidden. Then I will give the clear property. I'll say clear both. Still the container remains collapsed as the height of the content is still not there. So to sort this out, the display property works as a real charm. I will give display block. Now when I say display block, it's going to tell the browser to display the element on a block level. And you can see the container gets cleared and there is no more collapsing. So following this approach, we'll apply a small bit of content which remains hidden from the view as the parent container clears the floats. To sum it up, ClearFix is a way which tells the element to automatically clear its child elements so that there is no need for you to add the additional markup inside the document in order to clear the parent container. Now, there are still some browsers which do not support this approach. That is, giving the empty content. To be specific, browsers less than the IE8 versions, you will have to go with the older approaches which we saw in previous lectures, like floating the container element in the same direction as child or defining height in the collapsed container or adding additional markup inside the HTML, then applying clear property to it or giving overflow property inside the collapsed parent container, etc. There are still various ways to perform ClearFix, but that depends on what kind of situation you are dealing with, but this approach is quite popular and easy to use. Now that you have understood what floating is, I'll be showing you a few common approaches on creating float-based layouts. The most popular layout approach which various websites follow is the column layout approach. You may have seen or come across such websites. So let's try to implement a column layout with floats. I'm going to start by defining a header. I'll say my profile. Next, I'll define an article tag and I'll give 3 divisions inside, naming them as first column, second column, and third column. Lastly, I'm giving a footer. Alright, let's style them. I'll define width first, inside the body as I want to fit the content in this area. Let's style the H1. I will give the background color, aligning the text to center, giving some line height, text transform to uppercase, letter spacing and bottom margin of 25 pixels. Next, we will style the first column division. I am giving the background, border, height 100 pixels and width 120 pixels. We'll give some padding also, I'll say 1.5 rem, and we'll give some right margin. And you can see our first column is completed. Now I'm going to copy these properties and will rename the class to second column. Similarly, for the third column, I'll paste the same properties. We won't need the right margin for third column, so let me remove it, and instead let me add bottom margin of 25 pixels to create gap between the div and the footer. Now for the footer, I will give background and padding. You can see our basic structure is ready. Now to display them in column format, we have to apply floats to them. So let me give float left to all the columns. And you can see a 3-column layout is displayed. You can also notice that the footer is stretched all the way as the columns are floated, and right after the third column, you can see there is some space. This tends to happen when you float all the elements in a similar direction. So let's fix this. For footer, there is an easy fix, which is simply applying clear property. I will give clear both, and you can see the footer is back to its place. Now to fix the space in the third column, I will change the float direction to right instead of left, and you can see the space has been filled. Also, I will remove the margin from the second column as we don't need that anymore, because the width is going to provide the spacing between these two columns as they are floated in the opposite directions. So you can see there is no extra spacing to left or right. And you can also notice that the gap between the second column and the third is a bit off. You can fix that by slightly changing the width. Let me change the width of all columns to 136 pixels. We are now ready with our 3-column layout. So this is the technique which you can use for creating a 3-column layout. So by mastering the floating and clearing techniques, you can create the basic structure of any layout you wish to create. Just make sure that your layout allows flexibility and presentation the way you want. The display property allows you to specify the display behavior of an element. It is one of the most commonly used features in CSS development. As you know that HTML renders all the elements in a box, so the display property is used when you want to determine how that rectangular box should be treated, that is, as an inline element or block element. The default display value of most of the elements is either block or inline. So let's understand the display property with an example. I'm going to create 3 divisions inside the body, having the class names as first division, second division and third division. Now let me give same width and height and different background color to all the divisions. Right now the default value of display is block for all these divisions, and to check that, let me open the DevTools. I'll inspect any division and click on the computed, where you can see the display property as block. The block elements will always take the full width of space in the browser by default if not given specified width to the element, and will always start from the new line. Now let me set the display as inline for all the divisions, and you can see that all the divisions are in a single line now. So this is how the inline elements are displayed, that is side by side in a single line. You can also notice that the width and height is no longer affecting them because it is their tendency to ignore the width and height, as the width and height of inline elements are determined by the content they hold. Even if you give display inline to any block element, the height and width of that element will be ignored. Now there will be cases where both the display values, that is inline and block, won't be enough for a better web design. This is where the inline block comes to the rescue. As the name says, it shows the characteristics of both these properties. So let me give here inline block and remove inline from all three classes. And I'll also tweak this width and height in order to generate the desired result, which I want to show you. Right, this is how the inline block works. You can see the elements are arranged inline but also on a block level. You can also notice that now the width and height is working fine. So when you give inline block, you won't face issues regarding width or height not getting applied. But when displaying elements inline, their height and width will be ignored. Display property also allows you to remove an element from the view. So let me give display none to the second division. And you can see it removes the second division from the view. Not only it gets removed from the view, but also the display none removes the element completely from the DOM as well. This is why division 2 acts as an empty space, and thus division 3 takes up that space. If you compare this with visibility hidden, let me set visibility hidden in first division. You can see it hides the element, that is, it makes them invisible rather than removing it from the document. This means that the element is still there, and that's why division 3 is not taking that empty space. So these were some of the values which are widely used with the display property. Apart from these values, display property offers various other values like flex, flexbox, contents, grid, inline grid, list item, table, etc. We will check them in our upcoming lectures. Let's talk about relative questions. So the first question is, explain the purpose of using the display property. Well, it is used for specifying the display behavior of an element, that is, whether you want to display that element as a block or inline on a web page. Second question, differentiate between display none and visibility hidden. So display none will remove the element from the layout flow of the page, allowing other elements to take up that empty space, while the visibility hidden is going to make the element invisible, that is, it will hide the element but the space still remains intact. The third question is, why are width and height ignored on a displayed inline element? When you specify display inline to any element, or even if the element is an inline element by nature, giving them width and height won't affect them, because the width and height of any inline element is determined by the content they hold inside. When designing a website, you may think about what kind of layout approach you want to go with. That is, either you want a fixed or static layout, or you may go with fluid layout or responsive layout. Now, the decision of selecting a layout totally depends on the usability of the website, because each of the layout has its own advantages and disadvantages. Either one can be used to make a successful website layout as long as you keep usability in mind. So let's start with the fixed layout. Fixed layouts are static layouts whose width is kept fixed by giving pixel unit to the container. The container of a website is kept in such a way that it does not move, that is, it remains fixed at a position. That's why it is called fixed layout. No matter what screen resolution the device has, the width or size of the container will remain steady and will not adjust as per the device. Generally, for fixed layouts, there is a standard width size set for the container, and that is 960 pixels. Now, this width size is most widely used when setting up the container's width for a fixed layout website. But viewing such layouts on a smaller screen gets really messy, as in many situations a horizontal scroll pops up which ruins the flow of the website and overall experience of users. In fluid layout, which is also referred to as liquid layout, majority of components in a website contain percentage length values so that the layout can adjust with the screen resolution. Now, this means that whenever the screen size is changed, the elements will adjust accordingly in a proportionate manner. With the fluid layout approach, you can create more user-friendly and flexible websites, and also, if designed well, you can eliminate the horizontal scroll which appears when the screen resolution gets smaller. Another alternative, and the best one, is creating a responsive layout or responsive web design, also known as RWD. Responsive web designing is a modern approach for web designing, where the content renders smoothly and adjusts itself with various screen sizes, whether it can be computer, tablet, mobile, or a TV. It includes a combination of length units like percentages, viewport width and height, and several rules like media queries, so that the layout design can automatically adapt with the browser to maintain consistency across various platforms. Responsive web designs totally focus on handling screen sizes up to greater extent, as the contents are placed relative to the viewport's length. So these are some widely used designing approaches. Remember, all these layout approaches have their own pros and cons, but at the end, what's important is the designing of the layout, which should be done with some precautions, and that takes time and effort. Now, I'll talk about relative questions. So explain the difference between fixed, fluid, and responsive layout. Fixed layouts are static layouts in which the layout remains fixed upon resizing the screen, that is, it won't adjust with the screen resolution. Majority of elements are assigned with the pixel unit, be it their width, height, or margin. Whereas in fluid layout, whenever the screen is resized, the elements or the content adjusts itself accordingly, proportional to the screen. It makes use of percentage length unit rather than fixed pixels. And responsive layouts are much better than the fluid and fixed layouts, as the content renders smoothly and adjusts automatically whenever the screen size is resized or the resolution gets changed. It makes use of media queries and viewport units so that the layout is related with the overall viewport. In web designing, grids can be very useful when you want to deal with the phase of how and where to place elements on the page. It guides you for delivering consistent page content. Now, these guidelines incorporate margins, spaces, and columns collectively. Let's first understand the grid anatomy by creating an example first. I'm creating a container section, and inside, let me define 8 subdivisions. Now let's style them with background color, text aligned to center, border, padding 15 pixels, and font size. Right now they are displayed as a block. To make them display as a grid, CSS offers the value grid for the display property. So inside the container, I will give display grid. Now, when a container element is applied with display grid property, that element becomes a grid container. As in most cases, it acts as a direct parent of all the grid items, that is the child elements. By giving only display grid does not make the elements display in a grid, because grid layout consists of rows and columns. So after displaying them as grid, we need to define the row and column sizes. This is what gives a grid layout upper hand when compared with other layouts, as you won't need the floats and positioning properties with grid layouts. So let's apply columns and rows. For giving column and row length to a grid, CSS offers these properties: grid template columns and grid template rows. The grid template columns specifies how many columns with particular width you want in a grid. So if I give 4 values, it will create 4 columns grid layout. If I give 2 values, it will certainly create 2 columns grid layout. And if I give 5 values, it's going to create 5 column grid layout. As you can see, and the values are separated by space here. I will keep it to 4 values as it distributes the items equally. For giving the row length, as we have 2 rows, I will give 2 values. There can be some situations where there are many rows and columns. In that case, you cannot give individual values to both of them. So to avoid that, there is a function which is especially used with rows and columns, and that is the repeat function. So instead of giving individual values, you can give 2 values inside the repeat function. The first value takes the total number of rows or columns, and the second takes the height value for row and width value for column. And you can see this gives us a simple grid layout. Let me add 2 more properties. I will give margin and justify content to center. Now, talking about the flexibility, right now the grid is not flexible. As you can see, when I resize the output window, the grid stays the same. To make a grid flexible, you sure can use percentage values. Now when I resize the output window, you can see the grid becomes flexible. That is, it's getting adjusted with the window size. But a problem with percentage values is that they do not count or calculate the free space available within the grid container. To clarify that, let me give a border to the grid container, and you can see the grid is outside the container right now, and we don't want that. To avoid this, there is a unit which is specially made for the grids, and that is the fraction unit. The fraction unit works only with the free space available inside the container. It is also responsive and flexible. So let me give here fraction instead of percentage. I'll change the value to 2 fraction for columns width and 1 fraction for the row height. And you can notice as soon as the fraction unit is applied, the grid gets wrapped inside the container, and now when I resize the output window, you can see it does not overflow. You can also combine this fraction unit with other unit as well. Like for a moment, let me remove the row property and border, and also I'll alter the column values. I'll say 1 fraction, 1, 1 and 200 pixels for the 4th column. Now when I resize the output window, you can see the first 3 columns are responsive and the 4th column stays fixed. Let's try another combination with percentage value. I'll say 40%, 1, 1 and 2 fraction. So the browser assigns 40% of the viewport width to the first column, and then it divides the rest of the space into 1/2 fractions. These are kind of grid layout approaches you can perform. There is another useful property which you can apply to grids, and that is the grid gap property. This property gives space between each grid item. This space is often referred to as gutters in grid anatomy. Gutters are the lines between the columns and rows which separate each of the item. So let's apply grid gap property. I'll give 10 pixels and you see how each item gets separated. You can also give space between columns and rows individually by giving column gap and row gap properties. So instead of grid gap, I'll give column gap 10 pixels. You can see only the columns get separated, and row gap 10 pixels. This separates the rows. So this was some basic grid approach and anatomy which you need to understand and practice thoroughly. In the very next section, I'm going to show you some advanced and complex grid approaches where we will learn the spanning of rows and columns in grid layout. Now let's talk about questions. So how will you generate a grid layout with CSS? Well, you have to give the display grid property to the containing element, and then you define the rows and columns of the grid as we saw earlier. The second question is, explain the fraction unit. The fraction unit has been created just for the grid systems, as it works only with the free space available inside the container, making the grids responsive and flexible. The next question, how will you create a grid of specific rows and columns? By using a grid template rows or columns properties, you can define the number of columns and rows you want. Each value in the grid template columns also defines the width of the grid column, and in grid template rows, each value defines the height of the row. Next question is, what is a grid gap? Well, the grid gap is also known as gutters in a grid system is denoted as a space between the rows and columns, and to manipulate it, CSS provides the grid gap property, which is the shorthand for row gap and column gap properties. In the previous lecture, we saw how to get started with grids by understanding some grid anatomy and basic layout structure. In this lecture, I'll take grids one step further, as we will see how to create complex grid structures by spanning the columns and rows. Now by default, the content in a grid is placed in individual grid cells, but you can set any grid child to span multiple columns or rows or even both. I am going to continue with the same code which we saw in the previous lecture. So let's get started. You can see the output of this code. Let me set all the columns to one fraction first to understand the example in a better way. Now if I want to span the first content up to the column ending, this is how I will do it. Inside the item, I will specify the grid column start to 1 and column end to 5. And you can see it spans the 4 columns. These properties make use of grid column lines for calculating the column start and end. And the grid lines look something like this. So you can make out how the column spans. If I change the starting value to 2, then the A will start from the second column line and it will span up to the 5th column line. If calculating column line looks complicated, then there is a span keyword which directly tells how many columns to span. Let me add the span keyword before the value 5. Now you can see it spans 5 columns instead of 3. Remember, adding span keyword will not consider calculating the grid column lines. As you can see, the output is different from before. It's going to span the exact number of columns which is specified. If I again change the end to span 3, it will span 3 columns. Similarly for the row, let's span the row of B. I will give the start point to 1 to start from the first row, and I will give the end point to 4 for spanning. Looking at the grid lines, you can easily understand how the grid rows are calculated. Now, there is a shorthand for specifying the start and end points of the grid columns and rows. By giving the shorthand grid column and grid row, which takes two values, starting point and ending point, you can achieve the similar result. So let me comment these two lines and I will give the grid column property, keeping the start point to 2 slash and end point to 5. This is how the shorthand syntax looks. You separate these two values with a slash. You can also add the span keyword here for spanning the specific number of columns. I want to span 3 columns. I will write span 3 instead of number 5. Similarly, for the row, I will comment the first 2 lines and will give the shorthand, that is the grid row. Or you can span the number of rows by adding the span keyword. So spanning of elements is very useful with grids, as you can create a perfect web layout in a consistent manner. Let me show another example for creating a simple layout with grids. Let me give grid gap instead of row and column gap. Let me remove the comment lines from div A and change the grid columns to span for 5 columns starting from 1. For division B, I will again remove the comment lines and change the grid row starting from the second grid row and span for 2 rows. Also, let me give a height of 150 pixels. For division C, I will give grid column where I just want to span it for 3 columns. Here you can see we haven't given the value from where it has to start the spanning. So by default, it will start from its current position. Right now, the div C is located at the second grid column line, so the start position will be 2. You can see there will be no change if I write the starting position to 2 or just leave it. For division D, I will give span 2 rows. For division H, I will span 5 columns. And for child E, F and G, I will just leave it as it is. So our layout is ready. Now if I just assign them proper names, giving header, main content, sidebar, menu, sub-content and footer. Now this looks perfect. So this is how you can use grids to customize your own layouts, and there are many approaches to achieve or create any complex grid layouts. So now there is an assignment. You just have to create the following nested grid layout. You just try it out and come back again to check the solution also. I hope you have tried it. Let's see it together. I'm going to do some changes in the HTML code which we just saw. Moving this division E, F, G inside the division C and remove the text from division C. Let me insert a space before the child divisions so that it looks in the proper flow. Alright, so this is the first step. When you are going for a nested grid layout, that is, you nest the elements inside another element, now this division C acts as a container for all these subdivision elements. So inside the styling of division C, I will display this container as a grid. Then I will add 3 columns of 1 fraction. Next, I will give the grid row and will span 2 rows. And we have the desired layout. So this is how you create the nested grid layout. Flexbox, which is also referred to as flexible box, is a layout model which helps you design and create advanced web layouts, which are difficult to achieve using other layout models. Flexbox provides flexibility and overall control on how the elements are positioned, sized or aligned within their container, as you can flex the items to different sizes to fill the space or make them aligned vertically or horizontally, or maybe change their order of appearance or their direction, etc., making the design responsive and easy to work with. Flexbox is supported by all the modern day browsers, so it won't be having any compatibility issues. Flexbox offers a wide range of properties for customizing the container element as well as the items which are within that container. Some of the major benefits working with Flexbox is that it makes the making of navigation bars or menus very easy, in a way that you won't be needing any floats, so you don't have to worry about the elements getting collapsed. Creating grid layouts with Flexbox is an easier approach and very simple to work with, like creating equal height columns and much more. Now, before we move on to the properties used with Flexbox, it's essential to understand the terminology of Flexbox first. Observe this diagram. There is a Flex container which contains 3 Flex items. The Flexbox is used for creating one-dimensional layouts. So every Flex container contains a main axis, which is a primary axis along which the Flex items are displayed. The direction of the main axis is based on the Flex direction property, which we will see shortly. Then it has the main start and main end, which describes the main start side of the Flex item and going towards the main end side. Next is the main size, which is the width or height of the Flex container or Flex item, whichever is in the main dimension. Then comes the cross axis, which is always perpendicular to the main axis and its direction depends on the main axis direction. Cross start and cross end specifies the placement of items inside the Flex container, starting from the cross start side of the Flex container and going towards the cross end side. And lastly, the cross size, which is the width or height of a Flex item, whichever is in the cross dimension, becomes the item's cross size. So this was some basic information, some terminologies about the Flexbox which needed to be shared before we start working with them. Let's talk about a relative question. So what is a Flexbox? So it's a flexible box that is a web layout approach which makes customizing of complex web designs easy. It provides flexibility and overall control over the element's positioning, alignment, or size, etc. Flexbox can be created by giving display::flex inside the container element, though it's not just that which is going to implement the complete flexible box layout. When it comes to Flexbox properties, there are many different properties which Flexbox offers, and they are separated as Flex container and Flex items properties. I'm going to divide this Flexbox session into 2 lectures. One which we are going to see in this lecture will be about the properties applied on the Flex container, and the next second lecture will be about the properties applied on the Flex items. So let's start with an example. I will create a section with the class name as wrapper, and inside I am defining 4 items. Now let's style the items. For item A, giving the background, padding 2 rem and margin 10 pixels. Similarly, for the rest of the items, I will apply the same styling apart from the color. Now, as you know, by default, these items are displayed as block. To display the items as Flexbox, you will have to give the value flex. So I will give the display::flex property to the section. As you can see, all the items are displayed in flex, which is in a row-wise manner. Now there are certain properties which can be used inside the flex container. Let's give the justify content property. This property is used to align the container items when the items do not use all the available space on the main axis. So let me give justify content to center. You can see it centers the items. If I give flex end, it will shift all the items to the flex ending. If I give flex start, it brings back the items to the starting point of the flex container. Next useful values are space around, space evenly, and space between. If I give space around, you can see it adds the space before and after every single item. If I give space between, it's going to add space only between the items. And if I give space evenly, it will add space evenly around the elements. Next property I will apply is the align items. Now this property aligns the items on the vertical axis of the flex container. The first and default value is stretch. This value will stretch the items to fill the container. Right now you don't see the result because by default this value is applied to all the flex items. Let me give a border to the wrapper. Now if I increase the height of the wrapper, the inside items will also stretch according to the wrapper height. If I comment the align items property, still you can see it is working as this is the default behavior applied on the flex items. Let me undo the comment. Now let's try different values with align items. First, I will give different heights to the items in order to understand the align items property. As we have given different values to all the elements, the stretch property will not work and the default value of align items changes to flex start. Let me give flex start and you can see nothing has changed. And I'll apply flex end to the align items. You can see what it does. It aligns the flex items to the end or bottom of the container. If I change it to center, then all the items will get centered vertically. The next value is the baseline. Now what baseline does is it aligns the flex items along their contents baseline. In many situations, you won't be able to distinguish between baseline and flex start. As you can see, it shows me the same result, which we saw when I applied flex start. So how to make a baseline value noticeable? Simple. You can give some font sizes to the content. So if I give font size to the item A and item C, you can then notice how the items are getting aligned on the basis of their baseline. Important point with baseline is the alignment of the item will be determined by the tallest item in the row. Now if you change the value to flex start, you can understand the difference between baseline and flex start. So this is what align items used for. Next property we will look at is flex direction, which accepts one of four values, that is column, column reverse, row and row reverse. This property is used to display the flex items in a particular order within the container. The default direction value is row. Let me remove font size and heights from all the item classes to make it look better. Now the row reverse direction aligns the items horizontally in the reverse order. The next direction value is the column, which aligns the items vertically. Here we need to increase the height of wrapper. Let me change it to 30 rem. Now if I change the direction to column reverse, the items are getting displayed in a reverse order of columns. Let me set it to row for now. Next we have the flex wrap property, which defines whether the flex items should wrap or not. That is, it forces the flex items to stay in a single line or allows them to wrap in multiple lines. By default, it will not allow to wrap and keep the flex items in a single row. Let me resize the browser window and you can see all the 4 items are still in a single row. So giving flex wrap property with no wrap value will give the same result. Let me resize the window again to check. It is useful in the situations where you want your content or elements to be displayed in a single line and not distributed in multiple lines. Now let's set the value to wrap and resize the screen. You can see now the items are allowed to be wrapped inside their container. Next value is the wrap reverse. So let me apply that. The wrap reverse option is going to reverse the flow of flex items when they wrap on a new line, as you can see. The last property to be used on the flex container is the flex flow property. Now the flex flow property is more like a shorthand for flex direction and flex wrap properties. Let me apply flex flow and give the values row and wrap reverse. This shorthand is the same as we have defined flex direction and flex wrap properties in different lines. Let me comment those lines. You can give the values in any order, but normally this is the order which is followed, that you first give the flex direction followed by the flex wrap value. So these were the properties that can be applied to a flex container. Now let's talk about relative questions. So first is, how can you make any HTML element into a flex box? By setting the display property to flex, you can convert the HTML element to flexbox. The second question is how to align the elements to the right on the main axis using flexbox. So by setting the justify content property to flex end, you can align all the flex items to the right side on the main axis, that is the end of the flex container element. What will be the default wrap value for the items when a flexbox is created? It is the no wrap, which is the default wrap value, and it is set for all flex items whenever a flexbox is created. Explain the difference between flex start and baseline. So when you align the items to flex start, it will align the items to the starting point or edge of the flex container along the cross axis. But when you give the value baseline, it will align the flex items along their contents baseline. Explain the difference between align items and justify content. The align items is going to align the flex items on the cross axis of the container, whereas the justify content is going to align the flex items on the main axis of the container. So this is the main difference between these two properties. Previous lecture we saw different flex properties which you can apply to the flex container. Now we will move forward and look at the properties which are applied to the flex items particularly. I am continuing with the example we saw in the previous lecture. Let me just remove the flex flow property and set the align items property with flex start. The first property we will start with is the align self property. This property accepts the same 5 values as the align items, that is the flex end, flex start, center, baseline, and stretch. Align self property helps in aligning a single element, and it also overrides the value of align items assigned to all the flex items. So right now inside the wrapper, we have the align items property assigned to all the flex items. I am applying align self property to item B. I'll pass the value flex end. And you can see it places the item B to the end of the container, overriding the align items value given to all the flex items. Similarly, if I want to center align the item, let's say item A, you can do that by giving center to the align self, and that will center the item on the vertical axis. If I want an item to stretch to fill its container's size, I will apply the value stretch to the align self, and you can see it stretches the item to its container's length. The remaining values you can have a go at it, try for yourself and see how it works out. The next property for flex items is flex basis. So let me first of all remove all the align self properties and let me give flex basis property to item A. This property takes a length value, so I will give 200 pixels. And you can see the width of the item is increased. So a question may arise, why not just give the width property? This is where the definition comes in, that the flex basis property is used for defining the size of the flex item along the main axis, that is horizontal axis, which is by default. But when the flex direction of the container is changed from row to column, the size will be applied along the vertical axis, which we can say as height of the item. So inside the wrapper, if I add the flex direction to column, you can see the flex basis is now applied as the height. There are two keyword values, auto and content, which can be applied to the flex basis. The auto defines the size depending on the main size of the element. It will still be related to the direction of the flex container. That is, for horizontal flex, the auto will consider the width of the item, and for the vertical flex, auto will consider the height of the item. Similarly, for the content, it resolves the size based on the element's content. For all the values other than auto and content, flex basis is taken the same way as any other normal width or height in horizontal or vertical flow of the axis. Let me remove the flex direction from wrapper and flex basis from item A class to reset the look. Next is the flex grow property. This property grows the size of the flex item on the basis of the width given to the flex container. So first I will comment on the justify content inside the wrapper. Next, I am going to use the attribute selector to target all the items. I will give class and caret sign, which will target all the item names starting with the word item. Inside, I will give the flex grow to 1. Here 1 represents a number and not a length value like pixels, percentage, m, etc. Flex grow property is specified as a single number. Default is 0 and negative values are invalid. So when you want the flex items to fill up the remaining space, that is the size of the flex container minus the size of all flex items together, flex grow property comes in handy. Similarly to flex grow, there is the flex shrink property, which is exactly the opposite of flex grow. It shrinks the flex item based on the width of the other flex items. So if the size of the flex items is larger than its flex container, items will shrink when applying this flex shrink on them. So first I will give flex basis instead of flex grow. I'll give 200 pixels. Now I will apply flex shrink on item A. Let's give value 2. And you can see it shrinks when I resize the output window. Similarly, if I give flex shrink to item C, let me give 3 here, and it shrinks upon resize. The value of flex shrink specifies the shrinking level compared to the other items. Remember not to use the flex wrap property with flex shrink, otherwise you won't be seeing any shrink effect, as the items will get wrapped whenever the size of the flex item gets bigger than its container. So, make sure there is no flex wrap property before using flex shrink. Next property is a shorthand for the flex basis, flex grow and flex shrink, which is the flex property. Let me remove the flex shrink property from the items, and instead of flex basis, I will give flex property. The first value is for flex grow, second value for flex shrink, and the third value is for flex basis. This is how the order looks. You have to strictly follow this order for flex property. Lastly, the order property. This property is used for changing the order of all the flexible items. So if I want to change the default order of these items, I will do that by applying the order property. For item A, B, C, and D, I'll set the order as 2, 3, 1, and 4. And you can see the default order of flex items is changed. So these were the properties which can be applied to the flexible box items. Now let's work on an assignment. So the assignment is create a card view layout with Flexbox. Alright, I hope you have tried it. Now let's also do it together otherwise. I'll start by defining a section inside the body, giving the class name as wrapper. We will be applying the display flex property to this section as it is a container element. Now inside the section, I'll define an article tag with class name as card. Next, we need an image, so I will give the image tag giving the source alternate name and width 200 pixels. After the image, I am giving a div with class name as details, in which there will be a heading and some description inside the paragraph tag. And finally, a button which says read more. So we are ready with our first cards layout. Let me copy this and paste it 3 more times. Now let's style the card. So first, the wrapper, I will display it as flex. We'll set the flex wrap property to wrap and align the items from start. Next, styling the card, I will give border, margin, and flex property, setting the flex grow as 1, shrink as 0, and flex basis to 200 pixels. Also, let me set the contents to center aligned by giving text align property. I want to set the padding of the card and its details. And finally, for the button, I'll give a background, a border, font size, color, padding 5 pixels, width 100%, and border radius to 5 pixels. And so we have created a card view layout with Flexbox. You can resize the browser window and see how all articles adjust with the width. Though the browser takes care of calculations automatically, it is still very important to understand how this property calculates the spacing of the elements. Knowing this process helps you to understand it better. So let's look at the math behind the flex grow property. Let's work on the previous lecture's code. The only change I am applying is I'll remove the padding, margin, and order properties from every item. Next, instead of this flex property, let me give width of 150 pixels and padding of 2 rem and 0 to the items. And I will give the width of 700 pixels to the wrapper class. So we have added width to the parent element, that is the wrapper, and to the child elements, that is items. I have removed all the paddings and margins to understand how the flex grow calculates the overall width of an item, including remaining space as well. I'll now give some random flex grow values to each item. Item A will have the flex grow value set as 1, item B as 3, item C as 2, and item D as 4. Now let me open the DevTools and inspect the item. Let's inspect the item B. And you can see its new width is 180 pixels despite having width set as 150 pixels. This is how the browser does the calculations for the new width. First, the single flex grow value is divided by the total number of flex grow value. In our case, item B has a flex grow value of 3, so 3 will be divided by the total number of flex grow values, that is 10. Then that value is multiplied by the total number of available space. To calculate the available space, the width of the child elements is subtracted from the total of the parent element width. We have width set as 150 pixels for every child element, so the total would be 150 into 4, as we have 4 child elements. So by subtracting total child elements width from the parent element's width, we get the remaining, that is the available space value. After the available space is multiplied, the value which is obtained is further added with the width of that child element. By this, we end up having the new width value of that element, that is 180 pixels in our case. If I inspect item C, it has the width of 170 pixels. So if you calculate the figures using the shown formula, you get the newer width of the element. So this is how the flex grow is calculated. Media queries are very essential and important when it comes to designing a responsive web layout for various screen sizes like a mobile or tablet screen, laptop or PC, projector or a printer, etc. As it creates a view of a web page layout depending on the size of the viewport, which differs from system to system based on media types. So for viewing the web page across different devices, there won't be a need of writing new code lines which is suitable for a particular screen. You can just define the screen size or device type you wish to target inside the media query. This is what creating a responsive design means, and media query makes it possible. So for defining a media query, you'll have to give the @media rule in which you can add the CSS code for a certain condition. So let's take a look at the media query syntax. To specify any media query, we first declare the @media rule, then we give the media type, that is screen, all, print, and speech. These are the 4 types of media which are most commonly used. Then to specify the amount of screen to cover, which is also known as breakpoint, we give the minimum width, maximum width, prefixed with AND, which is a logical operator. 3 types of logical operators can be used with media queries, and they are AND, NOT, and ONLY. We can also specify orientation of the device, that is landscape, portrait, etc. Finally, inside the curly brackets, we define the CSS styles. All of these are considered as conditions, and when these conditions are met, the CSS code written in the media query is applied on the element. So let's create a simple example of media query. I will define an h1, 2 paragraphs, and a button inside the body. Now for the styling, let me apply simple styles to h1 and button. For h1, I will give color, font size of 3 rem. Button, I'll give background, setting the border to 0, color, padding 8 pixels, width 100 pixels and the border radius of 15 pixels. Now let's apply media query. I will say at media space screen, as we want to target the media type screen, giving and inside the brackets I will give a max width of 450 pixels. What this means is whenever the screen size gets to 450 pixels or below 450 pixels, it's going to apply the styles which I will define here inside the media query. So let me copy the above H1 style and paste it here. I will change the color and font size. Let me align the body as well. I will give body here and will center align it. Similarly, I'll copy the button styling and will modify few styles. Also, I will style the paragraphs. I will apply font size 0.8 rem and font family. Alright, now observe this. When I resize the output screen, as soon as the screen reaches the size of 450 pixels, you can see the media query is triggered and the styles are getting applied. So this is why the media query plays an important role while designing responsive web layouts. Let's apply another media query. This time I will keep the max width to 300 pixels. I will copy the above rules and paste it inside. We'll apply few modifications to them, and now when I further resize the output screen, you can see this second media query is triggered as the screen size sets to 300 pixels. So this is how the media queries are used. In upcoming lectures, we will see various layout examples as we dive deeper into this topic. Let's talk about relative questions. So what is the media query? Media query is a CSS technique which is introduced in CSS 3. It uses the media rule that includes block of CSS properties. It is the key part of designing the responsive web layouts depending on the viewports of the smaller devices. The second question is, how can you define the media query? So as we saw in the syntax explanation, that we first give the @media rule, then we specify the media type, that is screen or print, etc. And then we specify the characteristics and parameters of the device, such as screen resolution or max min width and height, etc. Now let's see a practical implementation of media query for mobile devices. I'm going to define a breakpoint at 450 pixels, meaning when the screen is 450 pixels wide or lesser than that, these CSS rules will apply. I will also implement a practical point, that is when there is a mobile device, there are different resources used. Consider this example where a site contains heavy contents like HD images or videos, etc. And when they are to be viewed on a small screen device, that device will have to allocate a few extra resources to have the contents rendered and viewed. So in some cases, those contents are skipped when they are rendered on small screen devices to save resources in order for the device to work smoothly. This is where the media query comes into picture. And this brings me to a question that how are media queries helpful when it comes to saving resources? So let's try to implement this example where we will have heavy resources that needs to be skipped when loaded on small screen devices. Let me continue with the previous example. I will add 2 images right before each paragraph. I'll set the width and height to 100% for both the images. Next, inside the media query having the max width of 450 pixels, I'll set the display property to none for the image. So this will hide both the images when the screen size shifts to 450 pixels or lower. I do not want to repeat the same line of code for the media query having the max width of 300 pixels, as the screen size reaches 450 pixels, it will implement this line of code for all the screen sizes which are lower than 450 pixels. Let me bring the output window to its full length. Now when I resize the window, you can see the images are getting hidden as the screen size reaches 450 pixels and lower. At the moment, because I am resizing, you see that images are getting hidden. Ideally, when it is opened on the smaller devices, the images will not be loaded in the memory. That's the advantage. That's where the performance will be improved with the smaller devices. So with this, the resources which are occupied by the device for viewing the images remains free. Now this is an important factor when the page is being viewed on a small screen device. The media all query is the query type which is used when you want to target all the devices. It is suitable for all device types. So let's create an example to understand it more clearly. I will start by defining a heading. Next, I will create a menu. So I will create a division, and inside I will define an ordered list and also list items with hyperlinks, that is anchor tags, having home, about us, contact and support as the text, and then a paragraph. Let's style them now. I'm giving color, font size of 3 rem and text align as center for heading. For UL, I'll give the list style to none, and this will remove the bullets, giving display property as flex and will justify the content to center. So this will center align the links. Also, I'll keep padding to 0 to remove any unwanted padding. Next, for styling the links, I'll give margin 1 rem, text decoration to none for removing the underlines, and then the color. For styling the paragraph, I will give padding 1.5 rem, top bottom margin 30 pixels and right left margin 50 pixels. Font size 1.2 rem, background and color. Alright, so we are done with the basic styling. Now let's make it responsive by adding a media query. So I will add the @media rule, and I want to target all devices. I will give the media type as all and will give the max width to 400 pixels. So when the screen size gets to 400 pixels or lower, the styles which I will add in this media query are going to get applied on the elements. By default, the media type is all. So if I don't specify any media type, the CSS parser will take the media type as all, but it's better to specify the media type when working with them. Alright, so let's style the H1. I will copy the above H1 styling and paste it here. I will change the font size to 2 rem and will remove the alignment. Next, I'll style the paragraph, giving font family, text align, center, font size 1 rem, font weight, bold and background. I'll change the display property of UL to inline block, and you can see it aligns the links vertically. And to add some space between them, let me add margin to li. I will give the bottom margin to 15 pixels, center aligning the division as well to make all the links appear in the center. And finally, I will style the links by applying just the color. Now when I resize the screen, you can see how the menu gets adjusted as per the mobile view. One more important point to remember is that the media query works just like any other selectors. For example, if I bring the H1 selector below the media query and resize the screen, you can see no matter what screen size it is, the heading styles stay the same because it is reading from top to bottom, and it always takes the bottom selector if the selector has the same specificity. Okay, so let me undo this and check the output again, and it's working fine. Again, to summarize, all will target all the media types, and it is a default media type taken by the CSS parser when no media type is specified. So even when I remove this all and, you can see it still works fine. But it is still recommended to give the media type explicitly, as there are still some bugs and issues faced by the developers when working with all. But still, if you want to target all the devices, you can go for it. Media type screen is used specifically for the computer screens, smartphones or tablets, basically screens. By giving the @media screen, you can target various devices' screen. So let's create an example. I will define a section with class name as main. Inside I'm going to define 4 divisions, each having a heading as column 1, 2, 3 and 4. Let's style these columns. I want to display them as a grid when the page is being viewed in desktop. So I will give the display grid to the main container, and I will define the 2-column layout of 1 fraction. Next, I will style the column by giving background color, border radius 15 pixels, margin 12 pixels, padding 14 pixels. Now I want to display this grid layout in a columnar layout when it is being watched on mobile or tablet devices. So for that, I will give a media query with screen as media type and orientation as portrait. I will display the container as flex and change the direction to column. So when the width of the screen is smaller than the height of the screen, it's going to convert the grid into a columnar flex layout. Let me style the columns as well. I'll copy the styles from above and paste it here, applying few modifications. And now when I resize the screen, you can see it converts the grid layout to columnar layout. This similar thing can be achieved by a different approach, and that is by specifying screen width sizes for different devices. The print media type is generally used when you want to print the web page on a paper. It is intended for paged material and documents which are to be viewed on a screen in print view mode. So let's move to the example. I'm going to define a section which will have a heading and 2 paragraphs. Let me now apply some basic styling to them. For H1, I will give color, font size 45 pixels and the text alignment to center. For paragraph, I give only the font size of 1.2 rem. Now I'll apply the print media query. If you want, you can specify the max min width, but for this example, I will just say @media print. I will copy the styles of H1 and paste it here. I will change the color, font size, and I'll give in point unit as they are widely used for printing documents. I will align it to center and will give the font family. Similarly, for paragraph, let me give the font size in points. I'll say 16 point and font family. Alright, if I resize the output page, nothing is happening because to see the result, I need to print this page. So let me open the page in browser. I'll press Ctrl P for printing the page and you can see the result. The color and the font size is changed as the document goes in print mode. The purpose of using the print in media query is quite simple. If the web page contains a lot of colored elements or various functionalities which are to be printed on the page, you can just apply the print media query with common colors shared by all the elements. This way you will be saving many resources and the need of printing the web page layout on a page gets fulfilled as well. For example, instead of giving different colors, if I apply similar colors to these elements And now when I print the page, you can see the elements share a similar color. So there won't be any clutter about the colors, and you can present the web document on a page with ease. Most of the time you will see that when you take a print, you will have the black and white combination. So that can also be configured inside this media print. So this is how the @media print works. Now let's talk about questions. So explain the difference between media screen and media print. So media screen targets the screens of particular devices like smartphones, tablets, PC, laptops, or any for that matter. Whereas the @media print is used for printing media, that is printing the web page layout on a paper. This is the major difference between these two media types. Designing or transforming the elements into 2D or 3D objects, or even animating them, has never been easier. As the browser got updated, CSS3 came into action with amazing capabilities of transforming the elements into 2D or 3D objects, animating and decorating them in the best way possible. This reduced the use of heavy GIF images, which were used for creating animated graphics, that led to faster loading of web pages, as CSS3 animations are extremely lightweight when compared to the GIF images, and this saved a lot of resources as well. All the modern day browsers like Chrome, Opera, Mozilla, etc. show full support of CSS 2D and 3D transform techniques. In this section, we will learn about 2D and 3D transform techniques, methods, and various other transform functions. When designing a website, many times you will have to position the HTML elements, or rotate them, or skew or scale them horizontally or vertically to enhance the look of the website. Now in CSS there are two types of transformations: 2D transform and 3D transform. 2D shapes basically take two axes, that is x-axis and y-axis. So we will manipulate mostly the x and y axis when creating a 2D shape, whereas 3D shape takes three axes, x, y, and z. So we will work with all the three axes for creating a 3D shape. Both of these transformations share similar methods and functions for creating 2D and 3D shapes. All these are considered as advanced CSS concepts, which we will now learn in this section. Using the translate function, you can move any element or text from their original position to any other X, Y, or Z coordinate without affecting other HTML components. So basically it repositions the element in horizontal or vertical directions. So let's practically implement this. I'm going to define two divisions, naming them as transform 2D and transform 3D. Applying background, padding, margin, and width to the first division, and paste these stylings in the second division as well. Now let's apply 2D transformation. I'm giving the transform property. This property is used whenever you want to give 2D or 3D transformation to an element. Next, I'll say translate. First, I will give only one value, say 20 pixels. Now, this is going to get applied on the x-axis, as you can see. For the y-axis, I will give the same value, that is 20 pixels. But first, I will make the value of x-axis to 0 pixels. You separate both these values with a comma. You can notice the movement of the element on the y-axis. If I further change it to 40 pixels, it will start overlapping the second division. Let me give x-axis value as well. I will give 40 pixels. And you can observe how we are moving the division on a 2D plane. You can also give negative values to the translate function. If I give negative 40 pixels, then you can see the division moves on the negative x and y axis. Let me bring it back to 40 pixels. The other version and a bit longer version of giving a 2D transformation to an element is by specifying the translate x and translate y. Translate is just a shorthand for giving 2D transformation. Now for 3D transformation, we will have to give three values, that is x, y and z. Either you specify the x, y and z axis values like this, or you can use the shorthand translate 3D function. Let me give the translate 3D function and first giving two values here, 10 and 10 pixels for the x and y axis. And now observe what happens. When I give the z-axis value, let's say 30 pixels, you can see after giving the z-axis, the element came above the 2D element. Also, I would like to mention that hierarchical order is also important. For example, if I bring this transform 3D division on top and change the y-axis value in translate 3D to 90 pixels, you can see the 2D division is now displayed above the 3D division despite not having a z-axis value. So you'll have to keep the track of hierarchical order of elements as well when applying any transformation. Let me now undo the changes and bring back to the code we were on. So what z-axis does is, instead of moving the element horizontally or vertically, it moves the element closer to you. Now many times there might be an issue of z-axis not getting applied, just like here. Even if I change the z-axis value to 50 pixels, you can see it is not getting any closer. To fix this kind of situation, CSS offers a function called perspective. This function takes a length value which defines a virtual distance between the plane of your computer screen and the HTML element on which you are applying the z-axis to. So let me add the perspective of 200 pixels here, and now you can see the 3D element comes closer as this z-axis is now getting applied perfectly, giving a 3D look. So what perspective did here is it created a virtual space of 200 pixels between the element and computer screen, and then it moves 50 pixels closer. Similarly, if I give negative value to z-axis, it will bring the element back considering the perspective as well. So this is how you can use the translate function to move the elements from its original position. Now let's talk about relative questions. So what is a transform property, or what does it do? So transform property is used whenever you want to apply the 2D or 3D transformation to an element, as this property offers various functions like translate, rotate, scale, move, skew, etc., which can be applied on the elements. What is the translate function and why is it used? The translate function is an inbuilt function of CSS to reposition the element either in the vertical or in the horizontal direction. It is used for moving the element from its current position based on the given x and y axis directional parameters. The third question is, what is translate z? The translate z is a CSS function that repositions an element along the z-axis in 3D space. That is, it will bring the element closer or farther away from the viewer. The last question, what is the perspective function in CSS? So the perspective function is used to give a 3D positioned element some perspective. It defines how far the object is away from the user. The transform rotate function is used for rotating the element to a given degree. That is, it rotates the element based on the angle that you provide as an argument. It rotates the element in a two-dimensional space, that is x and y plane. The rotation is clockwise and starts from 0 degree to 360 degrees. So let's move to a practical implementation. I'm continuing with the code we saw in the previous lecture. I'm giving the rotate function here. Let's say I want to rotate up to 25 degrees. And you can see it rotates the element 25 degrees on x and y plane. Apart from degrees, you can give radian, gradient, and turn. You can also give negative values with any of these units. So if I give here negative 0.9 turn, then it is absolutely valid. Similarly, we have the rotate x, rotate y, and rotate z, which are used for 3D transformation. So let's check these as well. First, let me just comment on this rotate function, and I will add a bottom margin of 100 pixels just to have the clear output look. Also adding left margin of 100 pixels for transform 3D division. Next, let me change the z-axis value to 20 pixels and will give the rotate y to 30 degree. And you can see it rotates the element on the y-axis. Similarly, rotate x, but first I will give 0 degree to rotate y, so you can clearly make out how the rotation is performed on the y-axis. And I will give 40 degree to rotate x. You can see that the rotate x rotates the element on the x-axis. And finally, the rotate z 15 degrees. It will rotate the element on the z-axis. Let me set the rotate y value again. And to give all these values together, there is a shorthand called rotate 3D, which takes 4 parameters. Let me give rotate 3D, and I will give the first value for the x-axis as 1. This function takes arguments as numbers instead of length units. The rest is y-axis and z-axis. I will keep them 0, and then the fourth parameter we specify the degree of rotation. I will give 30 degrees. The first 3 parameters specify the rotation direction along which the rotation will help, and together they form a direction vector x, y, z, which is used to apply the rotation. A positive angle value will rotate the element in the clockwise direction along the axis, and a negative value will rotate it in the counterclockwise direction along that axis. So right now, as I have given 1, 0, 0, it's going to rotate the x-axis only. If I give the y-axis value to 1, you can see how the y-axis rotation is performed. Let me give all 3 values. I will give 1, 1, 1, 30 degrees. This rotates the element 30 degrees on the z-axis as well. You can give negative values to perform counterclockwise rotation. Let me give -1 here, and it's going to rotate the y-axis counterclockwise. And yes, the values for rotation should be kept between 0 and 1. So this is how you can rotate any element along the x, y, or z axis plane with the rotate function. So in this lecture, we are going to see an assignment where we are implementing a 90 degrees rotating division. And it will look something like this. So once you finish this exercise, you're going to achieve this result, which you can see right now. You can try on your own, otherwise let's proceed further. So I'll start by defining a main division with the class name as cube. I'm going to create 2 subdivisions inside, naming them as front and back. I'll give the same heading as their class names to both of them. Now let's style the body. I'm giving text transform, uppercase, top padding of 3em and line height 62 pixels. Next, I'll style both the divisions, that is front and back. So let me give background, border. Now let me give height of 200 pixels. Let me also give some width. Next, we want a cube, so let's convert these divisions into a cube shape. I'm giving width 30%, text align to center, top bottom margin to 0, and right and left margin auto. And let me also give height to 200 pixels. Now we have a cube looking structure. Now we want this back division at the back side of the front division. So for that I will rotate the back division on the x-axis in negative 90 degrees. And this sends the back division to the back side of the front division. I'll also translate the division to z-axis about negative 100 pixels to make it come upwards on the z-axis. Otherwise, it will keep appearing below the front division, which we do not want. Now for the front division, I will give the translate z to 100 pixels to make it appear closer. Let me also give some top padding to h1. 40 pixels would be enough. And I'll set the perspective inside the body as well. Let's say 1000 pixels. And finally, the hover effect. I want to rotate the cube on hover, so I will give the rotate X to 90 degree to the cube. This will bring the back division to the front on hover. Right now, when I hover on the division, you can see it is flat and the back side is not getting displayed properly. To solve this, I will add a property called transform style. This is a newer property which specifies how the elements or nested elements should be displayed in 3D space. We will be seeing this property many times in upcoming examples. Right now I will keep the value as preserve 3D and will add a transition of 1.55 seconds. And now when I hover on the cube, you can see the front side is going upwards and the back side is displayed in front. So this is how you can use the rotate functions for creating animations like this. As the name says, the scale function is used for scaling the element's size. In simple words, you can alter the element's overall size. The scaling of elements takes place on both the x and y axis plane. Let's look at an example. I have defined divisions and have applied normal styling to it like padding, background, margin, width and height. Let me now apply the scale function on division 1. I will say transform scale x, as I want to scale this division on the x-axis. It takes a unitless number value as a parameter. I will give 2 and you can see it increases the size on the x-axis plane. 1 is the default scaling value of any element. Now if I change it to 3, the scaling of element on the x-axis keeps increasing. You can also give negative values. So if I give -3 here, you can see the text is reversed on the x-axis plane, which means the element gets flipped on the x-axis. Similarly, let me give scale y. I will first give the default value 1 to scale x and will set the value for scale y as 2. And now you see this scales the element on the y-axis. If I give -2 here, you can see the text getting reversed on the y-axis plane. That is, the element is flipped on the y-axis. There is also a shorthand which takes both x and y-axis values, and that is the scale function. So let me first give a single value, scale 3, and this will scale the element on both the axes equally. If you want to give separate values for scaling the element on the x and y axis, you give two values separated by comma. So 3 for scaling on x-axis, comma 2.5 for scaling on the y-axis. Now if you want to flip the element on both the axes, you can give negative values to both of them. So this is how the scale function is used for scaling the element on the x and y axis, that is 2D transformation. For three-dimensional scaling of elements, you specify the scale Z along with scale X and scale Y, or just give the shorthand, that is scale 3D, for specifying all three directions. So let's try that. I'm giving scale 3D function for x-axis. Let me give 2. For y, I'll give 1.5, and for z-axis, I'll give 1. In order to check the result, I will also add the rotate 3D function, as we do not have a 3D cube figure, and giving the perspective as well, 200 pixels. And now you can see the scaling of element on the z-axis as well. If I change the z-axis value to 2, it scales more on the z-axis. Let me again change the z-axis value to 3, and you can now easily make out the result. So scale function will scale the element on x and y axis, that is two-dimensional scaling, and scale 3D function is used for three-dimensional scaling, that is it scales the element on x, y and z axis respectively. Let's talk about the relative question. So what is a scale function? So it defines a transformation that resizes an element on the 2D plane. That is, it will make the element big or small. It resizes the element's horizontal and vertical dimensions on different scales. The skew transform function defines a transformation that skews the element, that is, it bends the element to a specified value as provided inside the parameter list. The transformation is done on a 2D plane, so you will have to specify the x and y axis angled direction. So let's implement it practically. This time let's take an image instead of an element. I will give the source and its alternative text. Let's style it. I'll give margin 110 pixels, width 400 and border. Now let's see what happens when we apply the skew function on it. I will give the transform property. Let's first apply skew on the x-axis. I'll give skew x 10 degrees, and you can see it skews the image horizontally, that is on x-axis. If I change it to 30 degrees, it will skew the image on x-axis 30 degrees. Let me give skew y 20 degrees, and I will make the skew x 0 degrees. And you can see the image skews on the y-axis. If I make it negative, it will skew on the negative y-axis. So skewing basically is kind of taking the opposite sides of an element and pushing or pulling them in different directions based on a given angle. And finally, the shorthand, that is the skew function, which takes two arguments. First value denotes the angle on x-axis and second value denotes the angle on y-axis. If you specify only one value, then it is used for the x-axis only, and there will be no skewing on the y-axis. So this is how the skewing of any element or image can be worked out with the skew function. So now let's try an assignment for skew function. Let's see a practical usage. I'm going to define a heading in a span tag. Let's apply style now. For body, I will add few additional styles. I'll display it as grid and will place the content to center, giving the minimum height to 100 VH. Next, the H1, I will give font size 3 rem, color, padding 2 rem and 4 rem, background and transform, rotate, I'll say minus 15 degrees, and skew minus 15 degrees. Next, let's style the span. I will give the display as inline block. As you know, span is not a block element. So in order to make the styles work properly on span, we have to convert it to a block element. I will give letter spacing to minus 0.2 rem to make the letters appear closer. And let me apply the text shadow property. Finally, I will add hover on span and I'll give letter spacing to 0 rem and cursor to pointer. Let me also add the transition of 1 second to span, and now when I hover the text, you can see it skews. You can also create a skew effect on the navbar menu or create a skew background design for web pages as well. You may have seen or heard about the matrix. A matrix in math terminology is a set of numbers arranged in rows and columns which form a rectangular array. But in CSS, matrix works differently. The matrix function is used for projecting linear transformations and displaying 3D images on a two-dimensional screen. So the matrix function is used for linear transformations and the matrix 3D function is used for projecting 3D images. The matrix function integrates all the transform functions into one, that is rotate, scale, translate, and skew. It takes up to 6 parameters and the syntax goes like this, where you give the matrix and then you give scale x, skew y, skew x, and scale y. You also give the translate x and translate y as well. Let's implement an example to get the clear idea. I'm going to define 3 divisions. The second and third division, I'm giving ID names as my div 1 and 2. Styling the division now, let me give width 300 pixels, font size 1.5 rem. Text align, I'll say center, padding 25 pixels, and margin, I'm going to give 20 pixels with some background color and border as well. I will apply the transform matrix on my div 1, so I'll give scale x as 1. If you remember, the scale method resizes the element. Next is skew y and skew x. I will give minus 0.3 and 0. Skew method skews the element, that is, it skews the element on the x and y axis. Next is scale y, I'm giving 1. Then translate x and translate y, so giving 0 and 20 respectively. And we are ready with our first set of values defined inside the matrix. This is what the syntax says. The first 4 values describe the linear transformation A, B, C, and D. And the last 2 values, that is tx and ty, describes the translation of the element to be applied on the x and y axis. So each value represents unique transform function methods. This is what the matrix method is all about, that is, to define all these functions in a single method. Now we will set a 3D transformation for the last division using the matrix 3D function. I will give transform matrix 3D. Now this function is an alternative to all the 3D transform functions like rotate 3D, rotate X, rotate Y, rotate Z, translate 3D, translate X, translate Y, and translate Z. Also scale 3D, scale Z, and perspective. It takes up to 16 parameters described in column major order, which creates a 4x4 matrix. So let me define the values. The first 12 values are for linear transformation and the last 4 values are for describing translations. This is what each value specifies. As these values are in column major order, the parameters as matrix elements will look like this. The A1 value describes the scaling on x-axis, A2 for the skew x on z-axis, A3 for skew x on y-axis, and A4 for translate x. Similarly, we have values for B1 to B4, C1 to C4, and D1 to D4. Note that in matrix and matrix 3D functions, the order of values are not in sequence. You will have to remember them as mentioned here. Normally, we do not see the matrix or matrix 3D functions getting used everywhere. Instead, the developers try to keep the code more meaningful by specifying individual functions for 2D or 3D transformations. Even if you know how matrix 3D works, that doesn't mean you'll know what values to provide it every time you do a transform. As you have seen, the numbers can get quite complex and you will need to be able to calculate each argument in your mind if you expect to use it in the same way you code the other translation functions. But anyways, you can go ahead and see how it works for you, because anytime you define a CSS transform function, you are affecting the matrix. For example, if I comment on this matrix 3D and apply rotate 3D instead, and when I open the DevTools and inspect the division 3 in the computed section, you can see the matrix 3D being displayed. So even with rotate 3D or any other transform function, you are still affecting the matrix as it determines the coordinates of the element, its size, position, orientation, etc. All these are represented in 16 parameters. Let's talk about questions of what is matrix in CSS. So matrix function is used for creating two-dimensional matrix transformations on the screen. This function integrates all these functions into one. In this lecture, I am taking a 3D card flip design with the help of transform methods we saw up till now. I am also going to use the Bootstrap logos for the card's face. So let's begin. I'm going to define a division with the class name as container, creating a subdivision named card. Now, as you know, a 3D card has two sides, that is front and back. So I will create two more subdivisions named face, face front, and face, face back. I will give the name Facebook here for the back side of the card, as I'm going to display the Facebook's icon on the front side. Also, you may have noticed I'm using a typical naming convention called BEM, that is Block Element Modifier. This naming convention helps you to achieve reusable components and code sharing at the same time. You will further get the idea when we style the elements with these class selectors. For the logo, I will head to the Bootstrap official site and click on the icons button on the navbar, and you can see the various list of icons that Bootstrap offers. I will search the Facebook logo, click the icon, and at the right hand side you can see the SVG path which says copy HTML. I will copy this code and paste it in the front division, changing the width and height to 50 and 35. And you can see the logo is displayed on top of the text. Let's create a few more cards. I'll duplicate the above card division and will remove the SVG path, giving the name as Twitter. I will duplicate this division 3 more times and I'll change the names to LinkedIn, Instagram, and GitHub. Now for their respective logos, I have already copied the SVG paths from Bootstrap and have set their height and width as well. You can see how the output looks now. First, we have the logo that's going to be at the front of the card, and then the name which will be at the back side of the card. Alright, so we are more or less done with the HTML code. Now let's style the elements. First is the container. I will display it as flex, applying width 100%, height 100 VH, justify content to center, align items, center as well, and perspective 1000 pixels. Let's style the card now. I'll set the position to relative, width to 6 rem, height the same, margin 0.5 rem, text align to center, line height 6 rem, and border radius to 0.8 rem. Next, I'll style the front and back. For front, I will give background and font size 3 rem. For back, let me give background, font size to 1 rem, and transform, rotate Y 180 degrees. So this rotates the text, that is the back side of the card. Now I will style the face, that is both front and back of the card together. So this is why the BEM naming convention is used, as it gives us code reusability and code sharing. So you will not have to write the code for front and back if they share similar code. You can also write like this, but for a quicker approach, you can prefer this one. Alright, let's apply styles to it. I'll set the display as block. Note that they are already displayed as block, but setting this property, I'm certain that the element remains as block no matter what further changes are applied on it. Next, I'll set position as absolute, top and left to 0, width 100%, height also 100%, border radius to 0.8 rem. I want to hide this text, so indirectly it goes behind, and for that I'll use the back face visibility property and keep it hidden. Some browsers don't support the back face visibility property, so we can use WebKit back face visibility property hidden, and this solves the problem. Next, I'll give hover effect to card as well as the front. I'll give transform rotate Y minus 180 degrees. This will send the front to back side when we hover it. Applying second hover effect on card and back of the card, I'll give transform rotate Y 0 degrees. Right now when I hover on it, this looks a bit rigid. Let's fix this by giving some transition. And transform style as preserve-3D to the card. I will hover on the cards, so this gives us the 3D card flip effect. CSS transitions are used for creating animations in CSS. When you give a transition, you change the value of a property and you tell the CSS to slowly change it according to some parameters towards the final state. A transition requires a starting point, that is the initial state, and an ending point, that is the active state, as any CSS transition that takes place is always triggered between these two states. For example, if you have an element that starts at an absolute position of 0 pixels having some color and ends at 250 pixels having another color, a CSS3 transition could smoothly animate between those two states without defining the individual frames. In order to trigger any transition, there has to be a way which starts the animation effect that ultimately reaches the end state. This can be done in CSS alone using pseudo selectors like hover, active, focus, etc. You could also trigger the animation by changing one or more of the element's style properties in JavaScript as well. In CSS, the transitions can be defined by following properties. The transition property is a shorthand for all these properties. So let's implement a simple transition example. I will define a division with class name as parent div, and inside I'll define a subdivision having class name as box rotation. Now I want to rotate this division 360 degrees and when the rotation is finished, its color should be changed. So let's apply style to the box. I will give height, width 150 pixels, background color, margin to 10 pixels, cursor as pointer. I'll say display flex, text alignment center, align items to center as well, and font size 18 pixels, font weight 700 and color, and also give padding to 10 pixels. Now I will give hover pseudo class on the box, giving color, background, border radius to 50%, transition to all, which denotes that I want all the properties for transition, and I will give the timing of 1 second. Transform to rotate Z 360 degrees. Now when I hover on the box, you can see the transition effect, that is, it rotates 360 degrees, changing its background, border radius and font color. And when I move the cursor away from the box, it comes back to its original state. Let me also give transition to the box and observe what happens. Now when I hover, it shows the result as we saw, but when I move the cursor away, you can see it rotates back to its original state. So I added the transition to the box for a smoother transition effect. Let me also center align the parent division. I will set the display property to flex, height to 95 VH, justify content to center, and align items center as well. This is just a basic transition I have shown, but as we move ahead, we will see many transition effects along with understanding different transition properties and their concepts. Now let's talk about a relative question. So what exactly is CSS transition? So it provides a way to control overall animation and its related aspects like speed using time, movement of transition effect, etc. when changing the CSS properties. In short, it helps you to change the property values smoothly over a duration. To apply transition on specific properties like width, height, margin or background color, etc., there is a property called transition property in which you specify the name of the CSS property on which the transition effect is to be applied. Let's check it practically. I'm going to define a division. Now let's style it. I'll give background color, width 200 pixels, height to 130 and font size to 2.5 rem. Let me also give padding to 20 pixels. Now I will give hover as well because most of the time a transition effect takes place when the user hovers on the element. I'll give width to 450 pixels. So right now when I hover, the width is increasing. Let's add transition specifically to the width. I'll give transition property, width, and we'll also give a transition duration of 1 second. Transition duration is just the property that specifies how many seconds or milliseconds a transition effect takes to complete. Now when I hover on the element, you can see it is getting transitioned in its given duration. If I remove the width from transition property and give font size instead, and when I hover, you can see the transition duration is no longer in effect because now I am specifying that I want to target the font size only. So if I add font size here inside hover, you can see upon hovering it is targeting font size with specified duration. So the font size is being transitioned within 1 second duration and not the width. This is what the transition property is used for, that is to transition a specific property of CSS. If you want to specify multiple properties, you just separate them by a comma. Like here, let me add width, height and background color, and inside the hover I will specify the height and background color as well. Now when I hover, these 4 properties are getting transitioned within the duration. If I remove any one of them, let's say background color, and hover again, you can see the background color is no longer transitioned. It's getting applied at the exact moment the cursor is placed on the element. Another alternative to define transition is to use the shorthand property, that is the transition itself, which you can try on your own. So if you want to use the shorthand, you can define like this. You give the property name followed by duration and each property separated by a comma. The transition property also has keyword values, none and all. If I give none, then no properties will be transitioned from the hover. And if I change to all, then it will target all the properties specified and they all will be transitioned. All is a default value, so even if I comment this line, all the properties are still getting transitioned. Now this may seem a quicker or easier approach for transitioning all the properties at once, but actually it's not. It's not recommended to use the value all for transitioning the properties. Always specify the property you are trying to transition. Because transitions are CPU intensive, but there are also transitions which rely on the GPU of a system, as your graphic processor can handle the transitions a lot better than the CPU does. But most of the time, it is the CPU that handles the transitions, which sometimes can cause poor or unreliable quality of transitions. So giving the value all can sometimes lead to inadequate transition effects. So it's better to specify the property on which you want to apply transition. Which leads me to a related question, that why is it not recommended to use the value all in transition property? So as I've mentioned, the transitions are CPU intensive and most of the time it will be your CPU that handles the transitions and animations. So by setting up the value all in the transition may lead to poor quality or inadequate transition effects. So it's better to specify the properties for transitioning. The transition timing function property handles how the actual transition should occur, as this property specifies the speed or acceleration curve of any transition effect. With this property, you can actually govern the transition effect to change speed over the time duration. So let's see how you can do that by looking at an example. I'm going to define a container division having a subdivision named box. Let's style the container. I'm going to display it as a slider. So I will give width 85%, margin 30 pixels, auto and 0. Border, and let me also give border radius to 70 pixels and padding to 15 pixels and background color as well. Now for the box, I will give width 100 pixels, height the same and border radius 50 pixels, and here also I'm going to say background. I'll give a hover on the container and will also specify box here. Let me give margin to 80% as we want to slide the box to the right upon hovering. Now let's add the transition. I'll give the transition timing function and you can see the list of keyword values it offers. I'll start with the value ease. This is the default value for all the transitions. Next, I will set the transition duration of 1 second. Let me hover on the box and you can see the transition effect with the value ease. Let's see the ease in value. With this value, the transition effect will start off slow and it will gradually increase until it reaches the end, as you can observe. Similarly, we have the ease out value, which starts the transition effect quickly and slows the effect as it continues. Next is the ease in out value, which is a combination of both these values. Here the transition starts slowly, speeds up in between, and then it slows down again. Next value is the linear, which transitions at an even speed. All these keyword values are simply shorthand for defining a Bezier curve. It is used in graphical addition softwares for defining a nice and smooth curve. The Bezier curve is the magic behind the timing function, as it basically describes the acceleration pattern on the graph. The Bezier curve is formed using the 4 points plotted on a graph, and as this curve is created using 4 points, in CSS it is referred to as the cubic Bezier curve. The cubic Bezier function is used with the transition timing property, which lets you access this Bezier curve. With the cubic Bezier function, you can manipulate the Bezier curve whichever way you desire, creating completely custom acceleration patterns for animation. So let's look at how this function works and how it enables you to create your very own Bezier curve. As we know now that the curve takes 4 point values, which are referred to as point 0, 1, 2 and 3. So I will give some random point values defining a Bezier curve. And now when I hover, you can see how it transitions. If I change the points again, you can see a different transition effect is taking place. So you can create n number of animation or transition patterns with the cubic Bezier function. And on top of that, every keyword value that we see here is defined on a Bezier curve, each having their own 4 point values plotted on the graph. Lastly, we have the step function, which displays the transition along the n stops of equal length of time. So if I give 4 here, it finishes the transition in 4 stops. If I change it to 3, it finishes the transition in 3 stops. All of these you can sum it up in the transition shorthand property as well. So CSS transitions are the easiest way to perform any animations. You can create transitions either with the transition shorthand or with transition properties. Remember to change your transition timing function so your animation looks more real. The transition delay property makes the transition wait for the specified duration as the transition comes into effect. So basically it tells at what duration the transition will start. The value of duration is defined in seconds or milliseconds. So let's implement this. I'm continuing with an example we saw in the previous lecture. In the hover, I will give transition delay of 1 second and background. Now when I hover, you can see after the duration of 1 second, the slide transition and the background color is getting changed. If I give 2 seconds, then the transition is going to get triggered after 2 seconds of delay. Let me specify another property for transition. I will give width inside the hover. I will remove the margin left and will give width 530 pixels. Now when I hover, you can see the width is also getting transitioned, but after a delayed duration of 2 seconds. If you want to specify different transition durations for different properties, you can define those properties with duration in the transition property. Like here, I am giving background color with duration of 2 seconds and width having duration of 2 seconds. Let me also change the transition delay to 800 milliseconds. And now when I hover, the transition is taking place after the delay of 800 milliseconds. You can also give negative delay values, like here I will give -1. But with the negative values, it removes the delay and effectively cuts into the duration, which you can see in the result. So this is how you give a delay to the transitions. In this lecture, we are going to create an example combining transform property with transition. This is going to be a kind of real world example which you can implement in your front-end projects. So let's begin. I will create a division named container in which I will give an image, a paragraph which is going to be the title of the image, and a button. For the button, I am using a division and an anchor tag instead of button tag itself because it's an easier approach to style a link rather than the actual button. Now I'm going to copy this container division and paste it 3 more times. Now let's style them. I'll start with the container, so giving the position to relative, margin top to 50 pixels, width 250, margin to 25 and height 150. I'll also set the display as inline block and the text align to center. Now for the image, let me set the position to absolute, width 250, height 150 pixels, left I'll keep 0 and background position, center and a transition of all 0.7 seconds and ease. Next I'll give the hover effect on the image. Want to scale the image when it is hovering, so I will give scale to 1.2. This will scale the image on both the X and Y axis, as you can see. Now there is a problem when the image is scaled. The scaled image is getting outside its container element. We do not want that, so for that I will give the overflow property inside the container. This will prevent the image getting scaled outside the container. As you can see, it creates a zoom-like effect on the image. Alright, so we are done with the styling of the image. Let's now style the title and the button. I will set the position to absolute, width 170 pixels, left 40, top to 15, font weight 700, font size to 25 pixels. Let me also give the text transform to uppercase, color and transition on top, 0.4 seconds and ease. I will apply hover on the container as well as on the title. Let me give top 0 pixels, color and text shadow as well. I will also specify the text shadow and color inside the transition property. And next, let me style the button, setting the position to absolute, bottom 15 pixels, left to 80 pixels. Let me set the opacity on the button to 0 and transition on opacity 0.35 seconds, ease and text shadow. I'll also style the anchor link, setting the font size 12 pixels, padding 5 and text decoration to none, which will remove the underline. Let me give the color and border. Now let me apply hover to make the button visible, giving the hover on the container as well as the button. I'll set the opacity to 1 and adding transform, scale 1.2. Lastly, I'll specify the transition on transform and opacity. And now when I hover on the container, not only the image is getting zoomed in, but you can also see the button and title getting adjusted and transitioned. When I bring the cursor to the button, you can see the image gets back to its default state, so this creates a lively feel. CSS animations are very similar to transitions in a way that allows smooth animation of CSS properties given to an element. An animation is defined as the change happening on the element in terms of its style or properties. And to apply the animation on the element, you have to first specify the keyframes for the animation, as keyframes take care of what styles to apply on the element at a certain time duration. Using CSS keyframe animations, developers can create smooth and maintainable animations that do not require writing long coding scripts. CSS provides a bunch of properties and rules that help you customize your animations. An animation is applied on the element using the animation property, which also helps you to create a looping of animation when used with keyframes. So you won't be needing JavaScript or any other frameworks to make a decent animation, as CSS provides a better and quicker approach for animating elements. Unlike CSS transitions, keyframe animations do not require a property change to trigger the animation. CSS animations can begin at any time, for example, when the page loads. In this section, we will learn everything about the animations done with CSS, understanding various properties like keyframe rule, animation name, animation duration, the animation direction, and much more. In CSS, the keyframes are used for defining the animations, or we can say animation code to be precise. As we know, the animations are created by gradually changing from one set of styles to another, and during the animation you can change the set of CSS styles many times with the help of keyframes. For creating animation in CSS, the @keyframe rule is used, which contains multiple animation properties. This rule allows you to apply different set of styles at different points throughout the animation. So let's understand the syntax with an example. I'm defining a division named slide. Let me apply some basic styling to it. The background color, width and height 150 pixels, and margin top to 50 pixels. Let me also define the keyframes rule by giving @keyframes keyword followed by the name of a keyframe. Name can be anything. Let me give the name as slide box. It is required that you give a name to the keyframes, as this name will be further specified in the animation property for binding the keyframe with animation. Next, we have the keyframe selectors. Now each keyframe will consist of one or more selectors, as each selector defines a point in animation that you would like to change or style. A keyframe selector has two keywords, from and to. The from keyword defines the point from where the animation starts, and the to keyword defines the point at which the animation ends. So I will give the from keyword here and will define a transform translate property inside. You know now what translate does. It moves the element on the x-axis if assigned with one parameter value. Let me give the starting position 0 pixels. Next, I will give the keyword to and will define the transform translate function. Let's say 450 pixels here, and rotate it to 90 degree. So this box is going to slide till 450 pixels length. And finally, after defining the keyframes, you have to give the animation. So for that, I'm using the shorthand animation property. First, giving the keyframe name, that is slide box, then the animation duration, that is 3 seconds, and you can see the animation is executed. Right now it only iterates one time. If I want a continuous iteration, then I will use the animation iteration count property and set it to infinite. And now the animation goes on. Here, maintaining the order of values is not necessarily required. You can set the values in whatever order that is convenient. You can also use the percentage values instead of keywords. A 0% represents the start of the iteration and 100% represents the end of the iteration. So let me go ahead and give the percentage values. I will give 0% instead of from and 100% instead of to, and you can see it works the same. What if I add another point? Let me add 43%. I will give border radius and will change the background color. Now whatever point you define is going to get multiplied with the animation duration. In our case it is 3 seconds, so 43% of 3 seconds. At this duration or point, the border radius and background color is getting changed. If I add another point, let's say 33%, and will give height and width, so 33% of 3 seconds is the point it will consider for applying these properties. So this way you can give multiple keyframe selectors, each representing a different point of animation. In this assignment, we'll learn how to create a bouncing ball animation using keyframes. So let's begin. First, I am going to set an image of basketball with width and height 100 pixels. I am defining margin of 100 pixels and defining the animation property as well. I want to loop the animation, so I'll specify the animation iteration count to infinite and set the duration of 1 second, naming the keyframe as bounce animation and keeping the animation timing function as linear. Next, I'll define at keyframes rule, setting the name as bounce animation, and inside I'll set the animation points. First will be at 0%, I'll give width and height 100 pixels and transform : translate y 0 pixels. Then at 10% I'll set the translate y to 10 pixels. Similarly for the points 20, 30 and 40%, I'll set the translate y to 40 pixels, 100 pixels and 200 pixels respectively. I'll define the different animation points till 100%, so let me quickly define them. The last point, which is the 100% where animation completes, I'll set the translate y to again 0 pixels. That will create a stop effect for basketball. And with that, we are ready with the bouncing ball animation effect. The animation name property describes the name which is given to the keyframes animation. It is used to select the keyframes rule that provides the property values for animation. Animation duration, on the other hand, specifies how long your animation will take to complete one cycle. Now this helps you to adjust the speed of the animation. It accepts time value, so a higher time value results in a slower speed, whereas lower time value results in higher speed of the animation. For example, let me define a parent division named myDiv, which will contain a subdivision named loader. We are going to create a loading bar animation. Now giving gray border of 2 pixels with 600 pixels and height 50 pixels and padding also 10 pixels to the parent division. Let me give the background color, width 10 pixels and height 50 pixels to loader class. Let me also define the at keyframes rule. I'll name it scale animation. I'll set the first point at 50%, setting the background color. And at 100%, I'll set the width to 600 pixels and background color. Lastly, I'm giving the animation property. First value will be the animation name, that is scale animation, followed by the animation duration, that is 1 second, and the animation iteration count to infinite. Let me remind you that the order is not important. You can also give any animation property first, it doesn't matter. And you can see the animation effect. As I have given a lower time value, the animation speed is quick. Let me set it to 5 seconds and you can see the animation speed is slower than earlier. So to sum it up, lower the time duration, quicker the speed, and greater the time duration, slower the speed. As simple as that. The animation delay property specifies how long the animation should wait until it begins the animation. Thus, it specifies a delay for the start of an animation. This property takes time value units, that is seconds and milliseconds. A positive value indicates that the animation should begin after the specified amount of time, and the negative value will cause the animation to execute immediately. For example, let me define a division with the class name myDiv. Let me apply the background color, width 150 pixels, height the same, and top and bottom margin to 100 pixels and left and right margin to 230 pixels on the division. I want to display the animation on hover, so I will give hover to the division, giving animation name myAnimation, animation duration to 2 seconds and the delay of 1 second. Next, I'll set the keyframes with the name myAnimation. At 45%, I'll give the border radius 50%, and at 100%, I will give transform, rotate to 180 degrees and scale to 2, also changing the background color. So now when I hover on the element, you can see the animation begins after a delay of 1 second. If I change the delay to -1 second, you can see it skips 1 second of animation and then it starts. You can also set these values inside the animation shorthand property. This time I am specifying the animation duration first. I'll give 800 milliseconds, then the animation delay to 2 seconds, and finally the keyframes name, that is myAnimation. And you can see the animation begins after a delay of 2 seconds. The animation iteration count property specifies how many times the animation sequence will be repeated. That is, it determines how many times it loops before stopping. If the iteration count is finite, then the animation will stop after a specified number of cycles. So let's see it practically. Inside the body, I am going to define the image tag and will set an image of boomerang. We will be applying animation on this image, so let's style it. I will start by setting the position of the image to relative, width 150 pixels and margin to 35 pixels. Now let's set animation properties as well. I'll give animation name to myAnimation, animation duration 3 seconds, and the animation timing function to linear. I'll set the iteration count after defining the keyframes. So let's set them. I'll define @keyframes rule with name myAnimation. At 0%, I'll set left 0 pixels and top 150 pixels. Also setting the animation timing function to ease in. Similarly, for 20%, 50%, and 80% keyframes, I'll set just the top and left properties. And at 100%, I will set top and left along with the animation timing function set to ease out. Done with the keyframes, but we are still halfway to achieve the final result. Right now, the animation is executed only once, which is default. So if I want to loop or repeat the animation cycle, I'll have to define an iteration count value. So inside the image tag, let me set animation iteration count to 3. And you can see the animation cycle is executed 3 times. If the animation iteration count is not specified, then it defaults to 1 and the animation cycle is executed only once, and the value 0 prevents the animation from executing. You can also give a decimal count value as well, but in that case, the animation cycle will stop before completing its final cycle. As you can see, the animation is repeated 2 times and then it stops halfway at the third cycle. We also have 3 keyword values, that is initial, inherit, and infinite. The initial value sets the iteration count to default value, that is 1. The inherit value will inherit the animation iteration count value from its parent element, whereas the infinite value is going to repeat the animation infinitely. This is the most commonly used value for animation and is used when you don't want your animation to stop on its own. You can sum up all these values inside the animation shorthand property as well. Again, the order is not necessary. You can specify the iteration count first and then the rest of the values. It won't make any difference in the animation. You can also give multiple iteration count values as well. This allows you to assign different iteration counts for different animations. So let's further add new sets of keyframes rules. I'll create a new keyframes rule named scale. At 0%, setting the transform scale to 0.5 and width 100 pixels. At 20%, width 150 pixels, and at 50%, I'll set the transform scale to 2 and width 300 pixels. At 80%, setting only the width to 150 pixels, and at 100%, setting the transform scale to 0.5 along with width 100 pixels. Creating another keyframes rule, naming this as rotate. For the points 0, 50 and 100%, I have set the transform rotate function, and at the beginning and ending frames, I have added animation timing functions. And now for the animation name, I will define 3 names here. For animation duration, I will define 3 duration values, and for animation iteration count, I'll set 3 count values. So listing multiple animation iteration count assigns each value to a value that is listed in the animation name in order-wise manner. That is, the first value of animation iteration count is applied to the first value of animation name and so on. This is how you can loop any animation by specifying animation iteration count. This assignment is based on the lecture we saw previously, that is controlling iterations. This is the animation we are trying to achieve in this lecture, so let's begin. Inside the body, I will define 3 image tags. The first one will be a document image with a class name file applied to it. The remaining 2 images are of the document folder with their class names set as folder 1 and 2 respectively. Now let's style them. First, I will style the document. So we'll set the position to relative, width 80 pixels, margin 100 pixels, 0, 0 and 50. I'll also set the animation property giving the name duration 2 seconds, animation iteration count infinite, and the timing function as linear. I want to set some common properties for both the folders. So I'll set their position to absolute, margin top to 100 pixels and width 150. For folder 1, I'll set the left to 0, and for folder 2, I'll set right to 0. Let's set the keyframes now. At 0%, applying the transform translate to 0 pixels. At 25%, applying translate function to 120 pixels and minus 75 pixels. Rotate function to 90 degree and scale X to 50%. Similarly, for 50% and 75%, I will set the translate rotate, and scale X functions. For 100%, I will set the translate 480 pixels, rotate 360 degree and scale X 100%. And by this, we are ready with our animation. With the help of animation direction property, you can control the direction of your animations easily. For example, let's say you want to move your animation left to right, back and forth, or in opposite direction. You can do that by using the animation direction property. So let's check this practically. I'm defining a division with the class name element, that is LM, giving styles now, width 100 pixels, height 100 pixels, margin 150 pixels, and border radius to 50%. Let me also give position relative, top and left to 0, and background color as well. Let me set animation properties as well, that is name, duration, and iteration count. Let's give keyframes now. I will set the keyframes name same as the animation name. At 0%, giving left 0 and top 0. At 15%, left 60 pixels and top minus 50 pixels. At 30%, left 120 and top 0. And at 45%, left 180 pixels and top minus 50 pixels. Similarly, for the points 60%, 75 and 100%, I will set the left and top property with different values. You can see the animation. Now let me define the animation direction property. I'll set it to normal. Normal is the default value for the animation direction. So if you don't give this property, then by default the value is set to normal and the animation plays forward by default. The initial value also sets the direction property to its default, that is normal. Next is the reverse value. By giving reverse, the animation plays backwards. As you can see, when it reaches its initial position, it goes back to its end state and animation starts from there. The next value is alternate, which alternates between normal direction and reverse direction. That is, the animation is played forward first and then backwards. And the last value is alternate reverse, which is the same as alternate, but in reverse order. That is, the animation is played backwards first and then forwards. You can either set the properties like this, or you can set all these values in the animation shorthand property like this. So the animation direction property is a quicker way to define a direction for animation. The animation timing function is used for setting the pace of the animation by specifying the speed curve of animation. For example, you want the animation to start slow, speed up in the middle of the cycle, and then slow down again at the end. You can do so by using the animation timing function property, which helps you to control the pace of the animation. So let's implement this. I am continuing with the example we saw in the previous lecture, giving here the animation timing function ease. Now ease is the default value, and you can see the animation. It starts slow, speeds up in the middle, and then slows down again. That's what the ease value does. Then there are values like ease in, ease out, and ease in out, which I am leaving for you to practice. We have already discussed these values in the transition timing function lecture, so you won't be having any trouble using them in animations as well. Next value I am giving is the linear value. This value keeps the speed equal throughout the animation. Next is the step function, which takes two parameters. First parameter is the number value, which should be greater than 0, and second parameter is optional, which takes either the value start or end, specifying the point at which the change of value occurs within the interval. Using the steps, you can specify the number of steps the animation should take before reaching its end state. Then we have the cubic Bezier function for gaining even more control over the animation's timing. The parentheses should contain two pairs of coordinates, so 4 numbers in total. These represent the x and y coordinates of 2 points on the curve. Both x values must be in the range 0 to 1. So when you want to customize the speed curve of animation, then you can use the cubic Bezier function, and to add this value in animation shorthand property, you can just specify the animation timing inside the property. So this is how you can control the speed curve with animation timing function. Let's talk about a relative question. So differentiate animation timing function versus transition timing function. Though these two properties share similar values, there is still a major difference between them. Any general animation is defined on multiple keyframes, that is, it can loop as many times as you want. They can run forwards or backwards, or they can alternate between the two. Whereas the transition is defined on 2 keyframes only, that is, it moves from one keyframe to another, executing only once, as they cannot be looped like animation. They are executed when triggered and are executed again in reverse when the triggered is removed. So this is what the difference is between the animation and a transition and their related properties. Let's begin with creating a background animation of a website. As the CSS3 animations are lightweight, rendering them is going to be much quicker. I am creating a division named My Heading and giving heading inside the division. Creating another division named Area. Defining unordered list inside. Setting the class name as circles and giving 10 allies inside. We are going to style these allies later on by applying animation on them. Let's apply styles. I'll first style the heading division, applying width 100%, position absolute, and bottom to 0 pixel. Styling the heading now, giving text align, center, color and font size 40 pixels. Styling the division area, applying a linear gradient background with 100% and height 100 VH. Now we will style the UL. I'll set the position to absolute, top and left to 0, width and height 100% and overflow hidden. Now we will style the lists, giving the position absolute, displaying lists as block, list style none, width 20 pixels and height 20 pixels. Let me also define bottom to minus 150 pixels and background as well. I'll set the animation, giving name as bg-animate, duration to 10 seconds, direction linear and iteration count infinite. We will define the keyframes later on. Styling the allies now, I'll select the first nth child, giving left 25%, width and height 80 pixels and animation delay 0 seconds. Selecting second nth child, setting left to 10%, width and height 20 pixels, animation delay to 2 seconds and animation duration 12 seconds. For third nth child, giving the left 70%, width and height 20 pixels and animation delay 4 seconds. And for fourth nth child, giving left 40%, width and height to 60 pixels, animation delay 0 seconds and animation duration to 18 seconds. Similarly, for the remaining allies, I am applying more or less the same styles as you can see. Finally, we'll set the keyframes. I'll give the name BG Animate. At 0%, I'm setting the transform translate Y to 0. I'll give opacity 1 and border radius 50%. Similarly, at 100%, setting the transform translate Y to -1000 pixels, giving opacity 0 and border radius 50%. And now you can see the animation in effect. Right now you can see that the document is not covering the whole page by observing the edges of the document. There is an easy fix to that. We just have to set the margin and padding to 0 for the whole document. I'll do that by specifying a CSS reset with the universal selector. We have already seen what a CSS reset is and how to use it. So I will set the margin and padding 0 pixels here. And now the document is covering the whole page. So I hope this gives you idea about applying the background animation. Unlike other animation properties, the animation fill mode property controls the styles of an animated element outside of its execution. In other words, it controls what the element looks like before the animation starts or after the animation completes. So let's implement it. I'm going to define a division inside the body, naming it as my div. Now let's style this. Let me set the position to relative, padding 50 pixels, margin to 60 pixels, width to 0 pixels, and let me give border as well. Next, I will set the background color and animation properties, that is animation name to animate, animation duration to 2 seconds, and animation timing function as is in out. Setting the keyframes now, we'll give the name animate, defining the start point, that is from left 0% and background color to left 55% background color, and transform rotate to 180 degrees. And you can see the animation. If you observe closely, you can notice that when the animation is over, it resets back to its initial position. With the animation fill mode property, we can change this. There are 4 main values: forwards, backwards, both, and none, which can be given to the animation fill mode property. Let's apply fill mode as forwards, and you can see when the animation ends, it stays at that position. So when you apply animation fill mode as forwards, the target element will retain the style values that are set in the final keyframe of the animation. So after the animation ends, it will not reset the styles. Note that the fill mode property depends on the animation direction as well. So if I set the animation direction to reverse, the final keyframe will be at 0%, and thus styles that are retained will be at 0%. The forwards value is probably the most common and useful value for this property. Use it to prevent an animated element from resetting visually after the animation finishes. On the opposite side, when the backwards value is assigned, the animation will take the style values set in the very first keyframe, that is 0% of the animation during the animation delay period. Animation delay sets a time delay until an animation begins, and animation fill mode will be applied during this delay. So let me define a delay of 3 seconds. Now when the animation executes, it adapts the styles from the first keyframe during the delay period. Remember, the backwards value isn't as widely applicable as forwards, but it may be useful with more complex animation sequences. Also note that setting animation direction to reverse will make the element take on the styles of the final keyframe of the animation instead of the first keyframe. Next is the both value. It applies the rules of both backwards and forwards. The element will adopt the styles of the first keyframe before the animation begins and the styles of the last keyframe after the animation ends. And lastly, the none value, which is the default value for animation fill mode property. The animation will not apply any styles to the target when it's not executing. The element will instead be displayed using any other CSS rules applied to it. Finally, the animation shorthand property, you can sum up all these values inside it like this. So this is how the animation fill mode is considered useful. It can help animations look cleaner and prevent them from resetting at the end of a sequence. In this assignment, we are going to create a sunset animation like you see in this preview. So let's begin. I'm starting by defining an image tag and will insert a forest image inside the document. Above this image tag, I'll define two divisions setting their class names as sun and moon. So we are done with the HTML part. Let's style them now. I'll set the image position to relative and will give top to 340 pixels. Next, I'll style the sun. So we'll set the position of that division to absolute, background color orange, height and width 100 pixels, border radius to 50%, top 4%, left to 15%, and a box shadow of orange. Let me also define the animation. I'll set its name as sunset, 5 seconds duration, ease in, and animation fill mode forwards. And you can see the sun is getting displayed. Let's set the keyframes for it. I'll define the keyframes rule sunset at 0%, the opacity to 1, at 50%, opacity to 1, and 100%, setting the transform to translate Y 450 pixels. And here we will set opacity to 0. And we want to hide the sun when the night animation starts. And we are done with the sun animation. Next, I'll style the moon, setting the position to absolute, border radius to 50%, setting height and width 100 pixels, background color to #FFF, that is white, and you can see the moon. Now to make the moon look half, we will set a box shadow of -20 pixels, 10 pixels and 2 pixels white. There are two moons right now and second is just the shadow. Next, I'll set the background color to transparent instead of white. And there you go with the half moon appearance. Now I will set the right 10% and will bring the moon to the bottom. So I'll set the bottom to 2%. We'll set the opacity of the moon to 0 and will also give the animation, setting the name as night 5 seconds, ease out 4 seconds delay and forwards. Setting the keyframe for moon at 100%, giving transform translate Y to -450 pixels and opacity to 1, and you can see both the animations. Now let's set the background animation, that is day and night. For that I will directly give the animation inside the body. I'll set the animation name as sky linear 5 seconds and forwards. Let me also set a reset setting to the margin and padding. Now let's set the keyframes. I'll give the animation name as sky at 0%, 35%, 55, 90 and 100%. I'll set different background color values for the day and night. And by this we are ready with sunset animation.